As we reconvene, I'm pleased to welcome you back to the afternoon session of this EV Summit. We have another jam-packed agenda for the rest of the day with a variety of exciting presentation and discussions on the future of electric vehicles. Over the course of this afternoon, we will dwell deeper into some of the key topics and challenges facing the industry, including digital engineering, battery technology, and charging infrastructure. I encourage you all to actively participate in the discussions and ask questions to our speakers. Let us make the most of this opportunity to learn, connect, and collaborate. So without further ado, let's get started with the first session of the afternoon, which is track 3 for today's summit. Let me invite Mr. T.R. Parasuraman, Executive Director, Advisor for the Toyota Group, also past President of BCIC, to speak on the future of manufacturing industry in the EV era. So your contribution to the chamber and the industry is tremendous. It would be good to hear from you.
Very nice poke. So very good afternoon, ladies and gentlemen. My job is very simple. This morning we heard a lot of stalwarts talking on diversity of topics, very holistic. So I'm just going to touch upon some of the future of manufacturing, the new era, and where we are going. Firstly, if you look at a country like India, one of the golden times happening in the country, the Amrit Kal, announced by the Prime Minister, because this is a golden age in the sense India is not only going to be a great economy, but also a great knowledge power of the world in the next decade. So this combination is a very unique thing that is happening for the country. If you look at India as a manufacturing, today we are at around 17% of country's GDP on the optimistic scale. Of course, we are at 12-13, but the latest budget estimates at 17% of total GDP. If you look at the countries like Western Europe, many advanced parts of United States, Japan, China, this is close to 25 to 30%. So if you look at India, 60% is service sector today. But the transition is happening more towards manufacturing. If you take China, the transition is happening from manufacturing to service. Normally, as the countries age, the shift is towards service. But India, the direction is reverse. We are going to be the youngest population of the world, huge demographics of dividend, and we are migrating from service to manufacturing. Because whether we like it or not, India will not only be a market for the country because of the huge captive opportunity, but also the factory of the world. Because you know that because of several geopolitical challenges, aging population, a lot of jobs are getting shifted out of China. So whether we like it or not, this is going to happen in the next decade. Therefore, the manufacturing GDP is going to grow by leaps and bounds on a very, very optimistic scale. It could be 30 to 35% of country's GDP in the next decade. So this is the real transition. And we have seen today, Mr. Bali was talking about last 4 years, $1.2 trillion being pumped into the infrastructure. And the next 4 years, $1.2 trillion are getting pumped. This Gati Shakti Yojana, which is going to build the bridges, transportations, logistics, plug-and-play parks, airports, and several industrial clusters across the country, that is going to be the game changer. And we have seen this budget, 12.5 lakh crores, 13.2 lakh crores coming for infrastructure, one of the biggest spends that is happening. Therefore, we can see the kind of changes that is happening in the country. So once these changes are going to drive, of course, we started with Make in India, Skill India, Youth India, then the PLI schemes, Atmanirbhar, and all those initiatives have really added to manufacturing. And today the PLI schemes, 198,000 crores pumped into the industry, and several initiatives on various sectors, including automobiles, new generation batteries, semiconductors, electronics. So this kind of a journey is continuing to complement the growth of the nation. So from this, what I could see, the automobile sector is going to see radical transformation in the form of new technologies, be it the hybrid, strong hybrids, EV, hydrogen, fuel cells, and agnostic technologies are going to really take the game. While at the same time, the EV mobility itself, the next 10 years, Indian growth is expected to be at CAGR 47 to 50%. This is very huge. By 2030, India will have around 1 million vehicles, 10% of the global population. And this is going to be a game changer. What you are talking is 30% private cars, 40% buses, then 80% two-wheelers and three-wheelers, 70% commercial vehicles. Therefore, you can imagine this is more of a practical skill. But having said that, if you ask me what is going to happen to IC engines, definitely IC is not getting into ICU. This for sure. At least in the next 20 years, there is a huge demand for these advanced engines. As EV keeps growing, the advanced technologies in the diesel engine, petrol engine, all are changing very fast. Noiseless engines, vibration-free engines, high fuel efficiency, lesser emissions. In fact, we have come out with latest Atkinson cycle, which is very fuel efficient, less vibration, and excellent fuel efficiency. And it has a 48% improved thermal efficiency. So this is a new Toyota, new architecture. This is the TNG engines have come. Similarly, many advanced technologies are happening in the IC engines as well. Therefore, this technology also will continue, but though the trend of EV will be much faster. As I said, CAGR could be 49%. At the same time, still several countries across the globe are still in Euro 4. So the transition is happening from Euro 4 to Euro 5 to Euro 6. India leap-bounded 2 stages from Euro 4 to Euro 6 in one single shot. That is the power of India. People asked whether it will happen, but it happened in India. We jumped from Euro 4 to Euro 6. And CAFE 2 is also advancing to the next level of CAFE 3 and so on. Therefore, the government is trying to do a lot of things on emissions. At the same time, the technology is growing on several folds. So based on all this, I thought 14 industries which are very crucial across the globe are going to emerge with the growth of EV. All are associated technologies, because we are talking about a sustainable future with sustainability. I think sustainability is a key word today in every walk of our life, be it industry, corporate, social responsibility. Thanks to the pandemic, it has changed the complete complexion of the game. The first industry, what we are talking is IoT. Internet of Things is really changing the world. It is so dynamic that every second month a new breakthrough happens. At least many years back, we used to listen, I am on internet. I am on internet. Internet is a very silo. Today, everything is integrated, be it computers, cell phones, household machines, appliances, all are on internet, all are connected. Therefore, IoT is going to change the face of the world, and it is growing exponentially. The second industry that is going to change is AI, artificial intelligence. Today, ChatGPT, you can do anything. Any kind of speech you say, it comes in seconds. You want a 2-page report, 3-page report on any topic under the sun, you get it in few seconds. It's so integrative. I remember the movie, what I saw, Indiran the Robo, Rajinikanth movie. Several years back, this movie came. I don't know how many of you saw this movie. So if you have to see AI, please watch that movie. Amazing. Millions of data. Big data is coming there. Data is analyzed in no time, and you get the optimal solution in seconds. The robo, the power of robo. I think AI is changing the face of the world because human beings' knowledge and brain is getting transferred. In fact, I was in one of the sessions in the World Forum of Society for Engineers. This year, Mr. Dalvi was also there. I was part of a committee. I was sitting with some Nobel laureates. The topic of discussion was how to substitute the human brain. We had several rounds of discussions. Finally, the answer was, it is impossible to substitute. Though we have come to 0.01% of substitution. Still, there is a huge. Nothing can replace the power of brain. Having said that, AI is moving towards that direction. So this is another game changer. Today, analysis is coming, which means it is able to think and analyze. Sophia, the humanoid computer, the humanoid robot has already got the citizenship. And you're able to see all these humanoids in disciplinary actions in research, development, and operations. So this is the second thing that is happening. Third is the cyber security. Because as the big data is growing in leaps and bounds, I think cyber security is very, very important, because to protect the information of the organization and also to ensure that the information is seamless. So several research is happening. In fact, in the Bachelor of Engineering, in the last couple of years, cyber security has come as a specialization. Computer science, cyber security. Artificial intelligence also has come as a specialization. So this is the third thing that is happening. And the fourth thing, industry which is going to take shape, is genomics. So the genomics, now I'm told, the next 5 years, this industry is going to grow by $400 billion. Because human genes, that genetic structure can be coded using AI, and you can get solution for any kind of diseases which has not been solved so far, be it complicated cancers or complicated growth in the body. I think genomics is going to give a solution that is also going to stretch the human life. Today, the average life expectancy has grown from 60, 70, 80. Today, genomics can give a new shape to this. Next industry is drones. Drones, you see so much of breakthroughs happening every day. You can see drones being substituted with Amazon messengers. All the food delivery will be happening through drones very shortly. All the courier services will be happening through drones. Drones will be supervising the military operations. Drones will be surveying the agricultural lands for effective yield. And drones will be the volunteers tracking various governments. And drones will be the key military agencies. That kind of activity is happening with AI, IoT, and all these associated technologies. Next industry that is going to grow in a huge way is robotics. Humans will substitute most of the industries. In my earlier speech, I said in one of the factories in Japan, it is run by two people, one a human being and a dog. The purpose of the human being is to feed the dog, and the purpose of the dog is to ensure that nobody enters the factory. I'm told one of the Sony factories. So you can imagine the robots are going to take charge of these factories, automated factories. We know that the labor cost is also growing in all the countries, developing economies, maybe in Indonesia, Thailand, India, and we have a lot of demand for quality at source. And people's skills are required in various other areas, the associated new technologies. Human brain is very, very precious. Therefore, for these monotonous jobs will be substituted by robotics. Robots will supervise the factories, they will run the factories, they will run the automated logistics plants, they will run huge warehouses, seamless warehouses, they can carry material, and I think this will be the order of the day. So next industry which is going to bring shape after the robotics will be the digital factories. Digital factories, what I mean is connected factories. Connectivity and digitalization will drive a lot of new technologies. Today everything will be connected. Human beings are connected, machines are connected, devices are connected. Therefore, this digital technology will play a very, very big role in terms of connectivity, be it the predictive maintenance or the condition monitoring. I am told that now the machine order is happening through this predictive maintenance. Whenever there is a spare is coming to an end, automatically the signal goes to the supplier in Japan, and he is preparing the spare and sending it to the factory. And exactly before few days, the spare is made available, so that we are able to save lot of man months in getting the spares. So this is going to be the order of the day. So digital factories are going to rule the. Then next thing what I thought was the nanotechnology. Nanotechnologies again are very, very fast growing, because today we are talking about all micro things. Therefore, these nanotechnologies are going to play a very important role in material science, bring new materials and new composites into picture. Therefore, nanotechnology will be another key industry that is likely to grow. Then renewable energy. I think today when we talk about renewable energy is the game changer for sustainability. And we talk about wind, solar, even geothermal we are talking about. So this renewable energy is going to be the game changer. Some speaker was talking in the morning. Today India is looking at EV, but well to wheel, Mr. Dalvi was talking. If you are not able to change the fossil to renewable energy, well to wheel has no meaning. Sorry, well to wheel has got a huge significance. Therefore, renewable energy will be the order of the day, if you really mean, because 80% today we are a fossil dependent economy. Then VR, virtual reality. Today, for example, as I am talking, my speech can be put in 100 languages in 100 locations across the world through holograms. You can't even differentiate who is the real Parasuraman and who is the hologram Parasuraman. I think that is the power of virtual reality. Today, simulations in factories, safety trainings, and all kind of trainings are happening virtually through virtual realities. This is assuming a greater significance. Then shared services is going to be the order of the day. The Gen Y, they don't want to earn anything. So everything is shared. Automobiles, rental cars, computers, houses, real estate space, office buildings. I think shared service is going to be the order of the day with connected technologies. Shared tourism. When you go to a particular tourist spot, today everything can be booked through internet, and all the Airbnb, all those things can be organized seamlessly. Then e-learning. E-learning is going to change the face of the world, because after COVID, we have seen what is the transition. 2 years, most of our children did not go to the school. Still, they managed to come out in flying colors. And when I look at the college situation, I'm able to see visiting professors talking all over the world, addressing on several topics. And I also happen to be in the governing board of a few of the colleges. So now the new mantra is how to connect seamlessly as a global village. I think this e-learning will really assume a greater significance in light of all these technologies. And the big data. I think big data is amazing. In fact, the challenge today, we have tons and tons of data. Analysis is missing in the today's world. So this AI is going to add a new flavor. This entire big data is churned into an analytical tool, and the crux of that optimal solution is going to be given based on the past experience, based on the diagnostics doctor tool. So this big data again is going to change the face of the industry. And 3D printing. Manufacturing is going to get seamless again. Today we are talking about printing in isolated locations, in some of the other planets, in rockets, in far-off locations where there is no access to the factories. So 3D printing is going to be the, again, game changer. Though in the immediate midterm, it may not substitute a mass production technique, but the kind of technological changes, breakthrough that is happening in the 3D printing is mind-boggling, because the composite materials, light materials, and hybrid manufacturing. I think BFW has launched the hybrid manufacturing machines, same as ACE machining systems. They have come out with very, very productive hybrid machine concepts, where a 3D printer can be compounded with a normal machine tool for producing high-speed mass manufacturing operations. So this is again 3D printed circuits We can print anything. Human organs can be printed. And even dentistry or on complicated operations, these can be reproduced in no time. And circular manufacturing will be the order of the day. Everything will be circular because of sustainability. Therefore, recycling, reuse to maintain the carbon footprint. And mass customization, because customer changes are happening every day. Customer is very, very demanding. Therefore, industry should suit the customer expectation for a dynamic operation. So, sustainability will be the order of the day driving all these new technologies. Thanks for listening. Thank you. God bless.
Thank you, sir. It's always good to hear from you. Taking sustainability from your speech, can we request Dr. Devarajan to give a sapling to Mr. T.R. Parasuraman?
Thank you very much. Thank you.
Stay in the middle. Thank you. Can I request the AV team to play a video to break the monotony of a lot of speeches? The topic is rewilding a forest. This is from TVS Motor Company.
This is a man-made forest that exists in harmony with an auto manufacturing facility. It would be hard to imagine that a few decades ago, this forest was no more than a dust bowl. Desolate, dry land which had no water and very little life. It was in 1979, when the TVS factory was set up in Hosur, that the landscape got a second chance. The founders of TVS believed that the environment, community and people are the delicate, indelible threads that hold the fragile tapestry of life intact. Their principle was simple. We humans must live and coexist in harmony with nature. From then, the TVS vision has been clear, that its factories and businesses had to inspire society to reach this larger goal. In a journey begun before conservation became a mantra for companies globally, a backyard that could have easily become a dump yard for factory scrap was transformed into a sustaining ecosystem teeming with life and plenitude. The commitment of TVS employees and the dedication and grit with which they took up this project has created a rich biosphere at their doorstep. In 1994, when the Hosur plant faced a scarcity of water, a retaining pond or water reserve was created at the northeast end of the property, near the Research and Development Building. Soon, that one pond grew into a network of water bodies that were added to the estate, putting back water into the aquifer and improving the overall hydrology of the region. It didn't stop with water, though. In a battle lasting several years, the notorious and invasive Suba Bowl, which covered most of the estate and the local area, was removed, so that the land could be rewilded with native species. TVS consulted conservationists to trace back native and endemic species and planted and nurtured them until nature took over. Water was life-giving, and the trees grew into a forest. It was a matter of time before birds and animals started calling this man-made forest home. Soon it was teeming with indigenous flora and fauna, native species of trees, birds, and reptiles that returned to reclaim their habitat. The reward of the hard work put in by TVS and its employees was witnessed in 2002 by the Chairman Emeritus, Venu Srinivasan, who while visiting the factory noticed painted storks sitting in the trees and wading in the depths of the pond, occasionally pulling out fish. The shy storks had found a new safe haven, and this strengthened his resolve to further the TVS commitment to conservation. Soon, scores of migratory birds made the TVS factory an annual stop on their route, not only staying for a while, but feeling protected enough to roost and give birth to the next generation. While TVS created nesting sites for them, many made their own nests. The true health of a forest is shown through the diversity of trees, the animal and bird life, as well as the different insects and decomposers that play a critical role in the cycle of life through an ecosystem. They break apart dead organisms into simpler inorganic materials, making nutrients available to primary producers. From life to death to rebirth, the cycle sustains. Nature lovers can spot animals more rarely seen, like the slender loris, and even the shy and critically endangered pangolin in this rewilded patch. Sand boas sun themselves in the open, and a variety of butterflies flutter around in abandon. Peacocks strut around unafraid. To the TVS employees, these forests are soothing, restorative counterpoints to the mechanical nature of factory work. In living in balance and harmony with nature, one finds an equilibrium within, resulting in greater productivity, prosperity, and peace. A movement that started 22 years ago with the planting of the first sapling at the TVS Hosur factory has now become a blueprint to be rolled out across all TVS manufacturing units. A little slice of paradise to inspire industry to exist in harmony with nature, and to teach the future generations that even the smallest of actions can be the start of lasting change.
That's true rewilding. I must congratulate the leadership team of TVS. It's fabulous and a very eye-opener. I mean, I wasn't aware of something like that. All right, so moving next. Top digital engineering trend in electric vehicles, design for immersive experience is the next topic, which will be delivered by Mr. Rabindra Shah, Chief Engineer, Strategic Projects, Global Practice, Automotive and Industrial Heavy Machinery, Tata Technologies. Mr. Shah has 30 years of experience with Tata Technologies and Tata Motors, strong domain of end-to-end product design to manufacturing domain, digital and physical both. He's a subject matter domain expert, execution and delivery, pre-sales and revenue growth. Please, Mr. Shah.
Good afternoon. Okay, next 20 minutes I'm going to talk on this particular topic. After a lot of thinking, I have picked up this topic, and And there is a word called immersive experience in my talk, which will get explained in next couple of slides. So I have made my presentation in two parts: technology for design and top digital engineering technology, which is driving call ACES, autonomous connected vehicle, electric vehicle, all types of electric vehicle, etc. To just share a background, automotive is my passion. 30 years I am in the automotive. I have worked for the all top automotive company in the worldwide. Being Tata Motors my parent company. To just brief, more than 100 vehicle program for commercial vehicle I have worked, starting from 0.7 ton of vehicle to 45 ton of vehicle, and entire life cycle of the product I have worked, and more than 10 physical plant I put up for the OEM, 9 in India, 1 in outside world. So when we talk about automotive, it's not only assembly line, it has got BIW, trim and all in digital, then on physical. And then recently, a lot of technology is evolving. So my talk will be that I come with the engineering services background as a Tata Technology, and we work on automotive, aerospace industry, heavy machinery, and all kind of technology we drive. And we have evolved from the Tata Motors only. So why I picked up the technology for design? Because I've been working with a lot of OEMs, tier 1, tier 2, and we see a lot of challenges comes when we bring the right technology in place for design of the product. So I'll just touch upon is that on that. This is a particular slide which talks about whenever we work on any automotive product design development stage. These are the typically we follow. Start with the concept design to development of the design, then design validation, prototyping, and then the prototyping, and then ramp up happen. A lot of parallel activities happen. At the bottom, you see the product life cycle is the base for the entire integrating is very, very important, and it very nicely we need to integrate the entire thing. That only we can realize the value. Otherwise, we'll move around. I have just put a slides which talks about majority of the agency which is involved in designing a product and manufacturing. In fact, the end to end. So which starts from the design, NPI project, and the sourcing, production, quality, sales and marketing, enterprise planning. Enterprising also they talk with the PLM software for data input and output, etc. So this is the very, very important, and we need to adopt the single source of truth, which is a PLM. There are a lot of technologies available. And if you do not follow it, then it lands up with the kind of not managing the data and just struggling for data to get in where it is lying there. So this is very, very important, and this technology is available for OEMs, for tiers, for SMEs, and all. Maybe the trimmed down versions are available, meeting their kind of requirement. Just Parasuraman sir was talking about your digital twin, which is the third project, which is a project and facility planning. The digital twin, to be very honest, while we develop the product design in the digital space, which goes to the kind of new product design, and we make the factory physically to make that product. So we build the digital twin. Digital twin is primarily application of the physical what we do in the digital environment. So more than 100,000 of the projects I have worked on for this as engineering services provider, not only limited to automotive aerospace. So this is very, very set for base, whatever digital technology you implement. We talk about Industry 4, different element of the Industry 4. The base remains the digital content which we create. And they all talk about that we have the production here, then the sourcing is the production is where we create the lot of the process sheet and standard operating procedure. That all come from this framework. So here we must, as a very key takeaway is that PLM annual digital thread continuity. Why we call it digital thread and continuity? Because the same source of truth goes to the all agency inside the plan, even the suppliers also. So it is very, very that everyone sees the same data, same source, and very effectively change management is done. And the CAD data, some organization has got a different set of CAD data. Someone who is X software, someone who is the Y software, or multiple software is in an organization. So this very nicely managed that, and it is scalable, and it gives a kind of your faster time to market. So challenges which I have seen, I have highlighted the challenges. Generally, we see that organization work on the point solution. Say they will have the kind of design one solution, manufacturing other solution. CAE, they will have a different 4 types of solution. And they all work on the point solution. So what the problem happens that the data continuity doesn't. You have to just check, export, import, or we need to develop the custom applications, read data from one format. There are a lot of PPAs in the world. So these are the challenges happen. What is happening is that I recommend that I call it the PLM van. Why we call is that this PLM van has got a kind of platform-based collaborative approach, which will only can solve your problem. Only just you need to subscribe any modules or any software you wanted to subscribe, just to subscribe to Reality, and all talks together, which is very, very important. And this is available in the on-cloud or in premises. So this is, I recommend technologies to be adopted, and this is available for the all SMEs level and the OEMs, tier 1, tier 2, etc., and the kind of the model which is required for the product design and development. I have just put a slide. I see a lot of students are also participating. This particular slide is very, very important. The product lifecycle, there are different technologies are there, and the product design is there, CAE validation is there, manufacturing there, metal flow simulation. Their forging and casting is very, very important. When I started career 30 years back, there was no metal flow simulation of forging. So at that time, the first in India, we evaluated some of the software, and we did the forging from say 10 gram of forging to 150 gram of kg of the forging, starting from a small sheet metal part of the forging to the crankshaft and to the connector. So this helps with the kind of you are making on the hammer or forge, how the metal flow is happened. So, and then a lot of things is happening in the AR and VR. There are a lot of technologies there. But in my career, almost 95% of the technology that I worked by the hands. And you can pick up any of the technology which suits you. I mean, you can work it for any of the area. So I put this kind of slides here. And I always says that whether you are working on the design or the manufacturing, and we set the flag on the PLM, until unless you do not complete the digital approval on the technology and the software, don't you take it to the physical world. So that's what you say, that always target to set up the process and flag on the PLM digital approval before any kind of physical work started. And this saves a kind of lot of time and the cost, etc. Whether we're talking about the battery, electric vehicle, hydrogen fuel, or hydrogen powered IC engine, or any other conventional things. And it gives us the kind of lot of the project management. Now we don't need to maintain the kind of separate solutions like the MS project management, other tools outside engineering space. But this technology nowadays provide entire integrated project management where we can link with the CAD geometry and etc. Also, I see the challenges of the product design is that we do the product design separately and CAE separately, and we have got a separate design. But over the period, my experience is that designer has to be given designer has to do the designing CAE-led. He has to do the first kind of CAE validation, whether he's doing the durability or doing a multi-body first level, to get a kind of quick iterative process to improve the design, and then probably he can have the dedicated team working on and collect the feedback. So this is the message, is that we need to integrate together the DG and CAE validation as a part of the design team, and the detail analysis to be carried by the separate CAE team to much more wider feedback. This particular slide I have put particularly, this is the technology, the talk which is being discussed across the OEM system engineering. System engineering very, very important when we are working the kind of connected vehicle, or we are talking about the advanced ADAS, we are talking about, or a lot of embedded technologies are happening, a lot of multidisciplinary things are happening. So this system engineering give an approach methodically, where requirement, we start with the requirement files, we do the functionality, we build the logical connection, and we do that. Then we start getting into the kind of digital verification, validation. So the technology supports that we should not miss out anything. It is available the system level, subsystem level, etc. And there are a lot of demand in this. And adoption, it was not there because of the kind of the vehicle, which we call the kind of digital, the vehicle, and we call a second living home as a vehicle. The kind of lot of infotainment and embedded systems are there. This is what is the right thing, where the mechanical, electrical, and other things come together and does it. And it saves a lot of time. Otherwise, get in the lost kind of problem. So having said that, the design technology, I'll take another, say 10 minutes. I have brought this particular slide after my studies, that I'm just only talking about 10 top technology which is driving the automotive, which includes electric, any kind of electric vehicle. And the way we think earlier, and I see the global world, that we used to go buy the vehicle, we think that yes, mileage is getting what, or the what is the other structural part is there. But now the consumer experience is totally changed, customer experience changed. They go to what feature, functionality, and immersive experience is being created by the product. That becomes the top priority for them to really decide the vehicle. I've been very closely working with Europe and the United States, and I see that these are the what driving. So I've just picked up the 10 things, and this is a great opportunity. Those who are in engineering services, those who are students, really build skills. These are the skills which is the top needed, because OEMs are funding money into this. Either they are funding monies to the startups, or they are funding into the outsourcing the work to there, or they are partnering, etc. So these are the 10 top. I'm going to quickly touch upon it. Let me start with the metaverse and gamification. This slide is very, very important, and I always hit really whoever is playing the game engine to develop the game or play the game engine. And always we see that the game engine is beyond engineering, but the game engineering is fully inside now engineering applications. So he has gamified the engineering application. So some of the things I have listed it down, and in subsequent slides we'll see that how the game engine is very, very really taking the engineering data, building the engineering solutions. I'm going to talk about. Parasuraman talked about the augmented virtual reality and other. There are many other things which are being done in the automotive. I'll just quickly touch upon it. If you see the extended reality, which includes the virtual reality or the virtual reality, augmented reality, and mixed reality, the market is growing very well. This is a great opportunity where you see the demand is there. I need to build these kinds of, and this is OEMs have got, engineering OEMs have got their own solution, but more flexibility, more immersive is available in the kind of the game engine platform. So this is what we see, that the growth is happening in the XR, and primarily we see that designing area a lot of happening, training area a lot of happening, and then the prototyping area. So this is the one slide I have just put it down. If you see the right hand side, there are the engineering software, non-engineering software. If you see the my right hand side, these are the game engine platform, and these are all put together to develop the kind of extended reality. And I'm going to show you about the next slide what is really being used this platform. And there are a lot of gadgets here, the below, which you can be used for the kind of visualizing the content. And this is taking a very major penetration in automotive, all the area which we shown that, and it is being used for the design review, it is using for the visualization. Though, in fact, I have got a slide on there. Next slide is here. If you see this slide, and this is purely from automotive perspective, how the design, manufacturing, training, sales, maintenance, repair, and sales and marketing, we use this technology, virtual reality. I myself is the developer I also develop a lot of content on this. You say the visualization e-learning kit or safety learning kit created, giving the dealers training or the maintenance training in sales and marketing. In fact, these are being used for the car configurator, creator, a lot of stuff visualization for the going ahead for the car. So these are the something which I picked up on the internet. There's nothing in Continental. You see this kind of visualization. You see this is the car, vehicle, and this is being rendered, visualized on non-engineering platform, the game engine. You can see the this kind of technology. I see the worldwide top 10, 15 are using this technology to do the kind of visualization. For doing the virtual productions, they are doing is a kind of sales and marketing stuff, creating so huge demand. And I've been recently in the United States and see that all top are using this and doing that. And it doesn't take much of time to just face. So if I have to say is that if you learn this within the few hours, you can build this kind of content. I am just put up one slide here. I recently experienced in the Auto Expo and in Hyundai showroom. And this is the kind of the metaverse has been created where you don't need to go physically. You have the kind of QR card, get into that, experience the vehicle, see the HMI, see the interior, see the digital cockpit, understand the product. And this is being enabled highly in kind of engineering and the game-based applications. So whatever you expect is there, and you place the order, and you have the kind of better. So this brings a kind of digital, physical very close together. I'm moving to the design thinking. If you see the design thinking we used to earlier, design thinking, but now design thinking playing a very, very important critical role. All OEMs are using it. Why they are using the spend? Because we are talking about new things, new come of the problem solution, new interfaces, etc. So this is a very, very important. So there is huge demand, and I see in the worldwide is happening. So this is a methodology, I'm limiting it. I have not taken the name of this one. So this is one of the OEM. He took 3-4 years to not to start with any company, but he did the kind of design thinking methodology framework world. And he come up with a product. He started based company, and he's now the billionaire. He started with the pre-order of the vehicle, and that too in the commercial vehicle. He's doing the best of best product he has come up, and that the design thinking process is enabled. So this is an example. I'm moving the state is that speed, agile, and the collaboration partnership. In the previous, Mr. Kali also spoke about the collaboration is that. So speed is very, very important. If you are not in the market, will not be there for the next 5 years. So we need to be ready, speed, jump, run fast to work, build the skill, invest in yourself. What skill, real skill is happening. Agile is a framework which is being highly used. Particularly, we are talking about ADAS, autonomous. A lot of OTT happens, a lot of small development happens. And we don't need to build the entire vehicle to come up. Just to put into the kind of create the sprint is a mathematics. A lot of opportunities are there, and automotive is highly using it. That how move from the waterfall method to the agile methodology. This is a very, very important slide. I have not put in the content on this, but I see that OEMs are putting reserve money. They can't do each and everything. They are going and spending money with the startup to give the challenge problem. They are solving it. Collaboration and partnership is the key things, very, very important. Any OEM can't do everything, can't do anything, everything, sorry. So he has to outsource it. So his collaborating partners is the next, which we saw in the early morning, etc. He was talking about the Volvo is partnering with others, BYD is partnering with others, Tesla, others are partnering. So this is the way collaborative development is happening, and this will speed up your success of the OEM. Going to ADAS is the Advanced Driving Assistance System. Myself is directly working on this in last 5 years. So this is one of the methodology is framed, and this is for the all branches, not mechanical, electrical, electronic, multi-disciplinary organized industry is working. Even the computer science people are driving. So this is a perception, sensor fusion, and planning and control happen. So I myself experienced the entire end-to-end cycles and build it. So this is what is the technology. I built a framework over here, and again, this is a framework which I have shared in the LinkedIn also. Is the framework of the MathWorks and the engineering software and the game engineering program. This is built, and this a lot of skills are required, lot of opportunity worldwide. Whole world is on this. Whole world, startup, etc. Someone is partnering, collaborating, etc. Including ADAS also is a part of this. So you can see is that how the road, etc. is built, and you can simulate in the simulation world, and then you can do the physically world, where the signal system. But domain is very, very important to learn about. So at least 20 such kind of worldwide top OEM vehicles I've studied and built the kind of knowledge. So I'm just moving very far. This is what recently ride I have taken. You can see that this is a self-driving vehicle is running in the San Francisco, and you see this kind of it's a midnight around 10:30 the PM. So much of nothing is visible. No perception of sensor, whether a camera or the LiDAR all work to give is a kind of fusion of the sensor to drive it. But it works. The technology evolving it. This is the vehicle of the Cruise. I took a ride on this, sitting on the air ride. So this is creating a lot of opportunity, the kind of framework. There are many solutions can be adopted, but it's really demand. Whether in India will come, but Indian company were doing a lot of engineering service for the globe. So one of them is us also. So just see it that this is a simulation environment. You can see the simulation about all rain, cloud, fog, road, glary, signing, all these kind of things. Put your all kind of sensors, etc., and visualize, simulate it, do the all simulation, then bring the control on top of that to work it. So this kind of complex scenario, because we can't do the physical test, etc. We need to do all kind of scenario environment, building, tree, bed, etc., and validate in the digital environment. And this will cut short your cycle, etc. So and this is again all this work is being done on the game engine platform, integrated with the engineering. So, and top OEMs are using it, you know, most of them. So I've just put in the kind of ADAS, a couple of slides, and these are the kind of small module, and where the lot of things are developments happening. A lot of Indian audio OEMs are working on this. Just skipping that. I put this, one slide here is very strongly, is that all this we are talking about the connected autonomous. These are the three things very, very important. Still, we need to gear up for this automotive cybersecurity, function safety, and assertive. These are the things which require, and it has the entire product lifecycle. It's not that the one part of that, it has to be supported with the entire lifecycle approach by the OEM. So this is the kind, and this works in the framework of the autonomous vehicle. So design for circular means we need to move from the linear to the circular. So we need to drop it down. And we need to start thinking of designing the product from the, not taking from the minerals from the mines. So we have to get out of that mindset. You have reuse, recycle, done. A lot of things are happening. Primarily focus is happening, and this is all the CEO of the mind, the dashboard. Three things are happening, all the CEO of the dashboard. Product, manufacturing, operations, supply chain. And supply chains are also geared up. And this is not only for the product design. Manufacturing plant is there where net zero emissions are happening. And when product lightweighting is one of that. But alternate material, interior design, which are the recyclables, the kind of things which are happening. So going at HMI. HMI is again engineering, game engine platform. These are the huge grooming demand. Even I see that OEMs have started making vehicle as well as they have started a services company and doing this kind of operation. So this is another revenue they are projecting as a part of their revenue. So mobility is going to be the second living home, and this is being created. This is the one I picked up, is available in the public. This kind of experience being created, this is from the BMW. See this video for a few seconds, you can make it of the kind of experience being created. This is what is the user needed. And now the customers, which is that how much experience Immersive we are going to create. So this is this kind of things, and all these in the simulation environment, and then before the putting it. So this is one of example. All of their models, variants are coming on this according to others. And this is again integrated with the engine and game engine platform. So just I'll take 1 minute last, I'll finish it off. User experience is the talk of the, I see that one OEM, so largest OEM, 35% of the employee are working on creation of user experience. 35% of the employee. Say he has got 20,000, 8,000 people are working on it. So this is one. OEM develops community. Now another thing is happening is that it's no more of selling the product. He's communicating, he's creating the loyal customer, he's involving his customer is a part of advisory. They are involving spending money to invest, give the idea, collect that. So this is the way it goes. So they will not leave the kind of the vehicle they buy it. So this is the trend. They are the clubs creating where the OEMs are pumping, and a lot of events are being created. PB and CB, I have put only that. We used to think that all features, safety function of a passenger car, I'm sorry. Now I see that all features are coming in the commercial vehicles, and it started with the pickup van, the delivery van, and that's etc. And ADAS, HMI, all are being in the commercial, which we hardly see. An autonomous vehicle is there. The last is that this is the trend now is emerging. Now buying vehicle is probably is not needed. You just subscribe it, rent it, flexible rate of monthly, etc. Anytime you want to change the vehicle from the one new vehicle to the other, we can do it. So this is a trend new is started in the automotive. So this much is that. Thank you. Any questions?
Yes. Thanks, Rabindra. All right. So we had 2 speakers so far. I think Mr. Parasuraman has left. Oh, sorry, is there. Any questions? Before that, can I request Mr. Prashanth, CEO of Continental, to felicitate Mr. Rabindra Shah. I would also request the manufacturing committee. While you'll be hearing Mr. Prashanth in a while, we had another task for him. All right, any question to the 2 speakers that we had so far from any of the audience?
From the EV point of view, what are the new skills people have to acquire for the electrical mobility?
Sir,
And which is going to be the driver in the future employment scenario?
yes. I'll look at from the commercial point of view, where the R&D expenditures are happening, where money is being pumped by OEMs, is the circular economy. How the material to be designed for circularity, how the new material can be invented, how lightweighting can be done in design and manufacturing is the talk of the day, and fund is being done for entire innovations. And skill sets are required for that. Say lightweighting, even the cars are working on, the racing cars are working, we forget about the commercial, etc. So this is the where is working. Second, sir, system engineering playing a very, very important role, which I put a one slide. The skill set is required. There is no skill set. In fact, I do not see any institute is providing the skill set on system engineering. This is. The third is that I put a one slide on the cyber security, functional safety, and sorting. These are all burning talk, and all OEMs and suppliers require it. So it's not there. No one is training. Only training some of the agency, and the charge of the training is very, very high. So these are the things which quickly come. Fund is there, budget is there, skill is there. Is needed. It's not being supplied. Supply chain, there is a gap.
Thank you, thank you.
Thank you.
Another question to Mr. Parasuraman, sir. Sir. Again, focusing on the topic of the day, electrical vehicle summit. In the aftermarket, Parasuraman, sir, in the aftermarket, when I visited Rabindra Toyota, nothing to do with Rabindra Saha, Rabindra Toyota, I see a beautiful table with some didactics for skill building. Can you give me some example of what Toyota is doing in the area of aftermarket training and skill building for the future of hybrid and electrical vehicle? Thank you, sir. Maybe Mr. Dalvi also can support you.
Some flashlights. See, a hybrid is really a kind of a game changer as a transition point to the electric vehicles. If you really look at our new High Rider and iCross. High Rider, we're talking about 27, 28 kilometers a liter of petrol. And iCross is giving around 20 to 23 kilometers. And my colleague, Mr. Dalvi, was talking about well-to-wheel. So I think this is what actually we are trying to focus as hybrid as an intermediary point, and ultimate landing point is electric or any other technology agnostic solution. Having said so, when you look at the skill sets aftermarket, so various skill sets are required in terms of maintenance, troubleshooting, connected technologies, engine, transmission, axles. I think basically the new skill sets, of course, are emerging, or how do we manage the electronics, power electronics, then the entire connected activities which are increasing. So this, we have a very, very systematic training schedule, where a documented skill development program, where it is very well trained to all the members. Then the master trainers train the trainers actually at Gemba, and ultimately standardized work. They should be able to repeat that work again and again to achieve quality at source. So this is done through a lot of visual manuals, simulation techniques, virtual reality, and such tools. So we have a very, very systematic program. Only one point I wanted to say, just since you asked this question. See, the future of EV in the current era, somebody was asking me whether I did not talk about that. I'll only take a couple of minutes. See, when you look at a country like India, as I said, it is still fossil dependent, even to the extent of 75-80% still it is fossil dependent. So the scope of renewable energy is very, very huge. Today, we're talking about solar energy and wind energy, which is abundantly available. And of course, nuclear energy is also catching up. So this is one big challenge. Once we have to migrate totally. Secondly, it is a supply chain itself. I think Mr. Dalvi was talking about motor, generator and battery, which is common across all vehicles, be it a hybrid car or fuel cell or a pure battery operated electric vehicle. Therefore, I think the development of the supply chain is still a long way to go, because motor, generator and battery technology today, it occupies 50% of the total cost. And solid state battery technology is still, a lot of challenges are there, because battery is deciding the drive range. So we are talking about today 400, 500, 600 kilometers. I think lithium ion development is very, very challenging, and sodium ion also is on the cards. And availability of this material in the country. Today, if you take China, see, many people are asking why China were able to take the lead. If you take, 4 important elements are constituting the battery. One is cobalt, one is nickel, one is lithium, magnesium. I think all these things, depending on the battery structure and combination, they make the right mix. But if you look at, let us say, lithium is coming from Indonesia. Cobalt is coming from Congo. And lithium is from Australia and Bolivia. And the cobalt is coming from Congo. And nickel is coming from Indonesia. And China has got a lot of reserves of bauxite and aluminium. But the refinement is happening only in China. All this refining is happening, so they control 90% of the trade. So which India has got huge reserves of titanium. So we are also, India, looking at titanium, lithium oxide, which is again a very powerful this thing. So titanium can be made in India, we have a huge reserve. And lithium can be imported to some extent. So this kind of a new technology, definitely government will be working on that. So we have a long way to go. So that is why the supply chain is quite complicated at this point of time, leading to a higher initial cost. And the charging infrastructure, which is a very big challenge, that fast charging infrastructure. Today the country has got 1,620 charging stations across the country. I think China has got 28 million or something like that. So there is a very huge gap, and I'm told that the BPL is putting around 10,000 charging stations in the next 3 years. And IOCL, I think they're coming with 7,000 charging stations. So this has to catch up with the kind of growth of EV in the country. I'm sure it is happening. So all these things are transitional. So it is happening step by step. That is why the hybrid technology will powerfully develop into an ultimate EV technology over a period of time, the supply chain development. Sorry,
Thank
sir.
you.
I thought I'll explain this.
Thank you, sir.
Thank
Thank
you.
you. Thank you very much.
Thank you, sir. Moving next. Mr. Karthikeyan is a thought leader driving industry innovations and technology adoption for manufacturing organizations accelerating their business transformation. He has rich experience of more than 37 years of engagement with the manufacturing industry. He was associated with Ashok Leyland early in his career, working in multiple departments and projects where he built much of his domain experience. In his role of CTO in EDS Technologies currently, he leads and guides the entire technical team, pre-sales, post-sales, custom application development, to offer superior customer experiences of the highest quality. Mr. Karthikeyan will be speaking on comprehensive EV development with industry-proven solutions.
Thank you. Before coming to the stage, I was warned I should not speak more than 10 minutes. So I need to see the time compression, like any electric vehicle manufacturer has the time compression. So today I am on presentation compression. So I will try to do my best to meet that. So though my topic is accelerator, so it is aptly placed how to accelerate presentations and how to accelerate development. So I will try to do my best. So I will skip all the point. Yeah, I belong to EDS Technologies because I am synonymous with EDS for last 27 years after my stint with Ashok Leyland. So I still call myself an EDSTN. So we have big company in India for last 27 plus years with 1,800 plus customers we support across the pan-India. So we have a leading partnership with many companies to support and service, especially the many industry technology company, how to support them. We need industry-supported solutions. So we are one-stop shop for many companies to support them, with which we address using these solutions for a respective industry problem. So I think there are many people talk today about this particular subject. So my talk would be to highlight some of the key points that we have already taken from the morning sessions. So I have just put some slides. There are charging infrastructure on one side, autonomous driving, connecting IoT. I think many people talked about it. Vehicle electrification is one of the subjects for which we are assembled today, how we need to take it forward. Then we have shared mobility, and then we have the public, the connectivity that we need to do. If you look at all these drivers, there are certain compelling value between industry to industry, which drives the other one. It is not on its own. It has its own weightage. It has its own relevance to each cross-domain. That makes business more complex. When you interconnect more systems, in-house, if there's only 2 people, simple. If there are 4 people, it is very difficult. Exactly, the business domain, as the members become more, as the ecosystem grows, you see a lot of expectations, a lot of things that need to be addressed, which is making the more complex in terms of mapping the requirement and delivering. So I have just put simple slides here, which clearly talks about what are all the factors that dominantly talk about. Today, the battery is synonymous with electrification. Though there are many components drive, but battery is the only thing that comes to the mind if it is EV. When you go, do you have a battery to change? No other people talk about other than battery. So battery becomes the highest one. But battery is followed by the electric drive, and today people talked about power electronics, what is required to be supported. And today Ashok clearly talked about the architecture. It is not simple that just put batteries into the system, but you need the size and scale based on the market demands. So the challenges are really phenomenal unless you really visualize it and upfront in the design process. That is very important. If you look at the two-wheeler industry, I have highlighted in 2 or 3 colors, which just to show you where the data is going, where the communication is happening, how the interactive systems are becoming more complex now. This clearly gives challenge not only to the electrical engineers, mechanical engineers, electromechanical engineers, the new job roles, which somebody asked me a question. Now there is a dimension called electrical and mechanical together. In earlier days, I, as an electrical engineer, mechanical engineer, never discussed with an electrical engineer in the past. I don't even walk through the department. Only for the first year I walked through. But today, the subjects are synonymous. You need to interact today. Unless you interact and learn more together, you will not be able to find a useful skill that is required for you to be employed. So digital vision is an important aspect of the industry today. The digital vision is required for many companies to drive, which is very important for packaging. 3D packaging is one of the subjects that we talked about. The other one is the validation that we need to do upfront, because we cannot do prototypes and finally come back and say it's not going to work. You need a prototype. Verification and validation is a very important point. Many people do it physically. Some people do it digitally plus virtually. So it is better to do virtual world sometime so you can minimize the physical world efforts. If you look at the prototypes, which I talked about, the 3D concept is because the electrical vehicle is demand, but if you look at in the market, more people wanted to add new visual appeal. The visual appeals are going to be based on concept that you would like to drive. The wiring harness design, the power of the wiring harness is going to drive how much electricity that you would like to carry forward between system to system. That is very important. The third one is you also drive the e-drive, which I think earlier people much talked about it. Then the last one is vehicle system, architecture and engineering. So if you look at it here, there are a lot of aspects of battery being a critical function. So I think some of the companies which are here, they specialize in this in terms of selection, shortlisting, grouping the right size of batteries. That means battery cells, how to package it, how to do the thermal management is a very important part of the vehicle because it is the fuel of the vehicle. So the grade of the fuel that you use in your vehicle to give a better mileage. So similarly, the battery decides your kind of a run for the engine for the vehicle to run. Similarly, the collaborative part, I think Rabindra talked more fully about the BOM management, digital mock-up and validation. I don't want to bore you with this slide since it is already covered. So this slide, sorry, did I miss? Okay, I missed one slide. Okay, this slide talks about there are certain areas which I would like to touch upon. In the electrical design, that is becoming more complex now. It is important that you need to have library of parts in your software application, which will able to simulate all kind of a testing and validation that you can do faster. So we have signed up with Synopsys, which helps us to really do this kind of an effort seamlessly for many companies to evaluate quickly the system engineering module. It also helps you to really validate lot of virtual, in the current model of the world, the availability of chip is a problem. So if you have to get your ECUs or chips that you need to bring in to make a physical device, it takes more time for you to validate. So we can even do that completely through virtual ECUs. You can build and validate the whole cycle in order to prove your vehicle is worthy enough for the road validation. So this is about the mileage modification that you would like to do in terms of improving your mileage, especially electrical vehicle. Range optimization is one of the key criteria for many electric vehicle companies today. Differentiation, one of the key differentiation is I offer 300 kilometers, somebody says I'll offer 425 kilometers. So it is something similar to what your mileage, what people talked about in the IC engines. Even here people come end of the day with a number of kilometers that I can go between charge to next recharge. This is going to be one of the key KPI for many companies to define how to impress the consumer or a customer. So these are all my customer credentials. Some of them are here in this room, some of them are outside this room. I think this shows clearly how we are able to collaborate and cooperate with many of the EV industry to contribute, especially the two-wheeler industry's fast adoption, because of the market demands are very high, and these people are more technology aware about it, and then they are adapting it in a faster rate. So we thank you for all that patience, and you name the who's and who of the two-wheeler industry. They are all my proud customers, and they made us learn more about how to deploy technologies, how to put this technology to the best use. So this is the electric mobility accelerator. 3 topics I talked: digital vision, performance-driven prototype, and collaborative development. These 3 are the pillars for the digital vision for many companies to accelerate EV mobility. Thank you for the patient listening. I think I was good enough on 10. I was yesterday's last over, 5 sixers yesterday, one guy has hit in. So I tried to hit the 5 sixers.
Now let me request Mr. GV Rao to come and then hand over.
Incidentally, he's my colleague in Ashok Leyland.
Oh,
So
yes.
you got the right person.
I was prompted to ask him to come on. Sir, please.
Thank you very much. Thank you.
Otherwise, Rabindra will be unhappy if I don't show his head.
Thank you.
Thank you. Thank you, Mr. Karthikeyan. That helps us moving forward. Moving ahead, over 3 decades of work experience in the automotive industry, strong legacy of consistently achieving non-linear business growth, facilitating change management and leading organizational transformation across different business verticals and cultural paradigms. Extensive in-depth domain knowledge spanning across automotive electronics, user experience, architecture and networking, safety and motion, smart and autonomous mobility. Mr. Prashanth Doreswamy is the President CEO at Continental India, and he will take us through the technologies beyond EV.
Okay, good afternoon, everyone. I didn't realize. Thank you, Dr. Devarajan, for this opportunity. Really pleasure to be part of this great event here. So I thought I'll briefly talk on a different subject, which is technologies beyond EV. All of us think Tesla is very successful today because he came out with an electric car, which is untrue. Because he combined many other technologies along with EV, that's how he has been successful. So I will cover those through my slides. Yeah. Now talk about EV. I know all my previous speakers have spoken enough about that, so a couple of slides I'm going to run fast. If you look at the internal combustion engine development, I think the last one will happen in 2025, which will come into production by 2030, and by 2040 it will be out. Beyond 2040, everything is going to be electric vehicles. So this is the status as on today. This may even get advanced if there is an economies of scale. Now talking about emissions during, say, an average 200,000 kilometers, this is what each of the technologies contribute. I think earlier my colleagues also spoken about this, so I'm not going to dwell on this. But the only difference, if you see in the car production, 10% of the energy is consumed during production. Whereas for electric vehicles, it's 20%. That's one challenge today we have. So going forward, how do we ensure as we produce more electric vehicles, reduce that consumption of energy in the production of vehicles for electric vehicles? Now, talking about this, today car is maybe in 70s, 80s, 90s, we saw car as a purely mechanical part to take you from A to B. It had only metal, rubber, plastics. But today, if you see, it has become an extended IoT device. We all started experiencing comfort at home few years back. And last 3-4 years, we started seeing that comfort at office. Now we started as a consumer asking, why can't we have that comfort sitting inside the car when I drive? But bringing this technology, it's not easy into automotive because safety comes into play. So it has to be a combination of technology plus consumer behavior plus regulation. Why do I say this? You heard about A's or K's since morning, right? But if you talk about connected, automated, safer vehicles, it's more driven by consumer preferences. It's more evolutionary in nature. If we talk about electrification, it's a revolutionary in nature. You and me don't prefer an electric car today because it costs more. It is forced on us by regulations, by governments, by cities. That's the situation today. So there's a challenge. So if you have to make it successful, it has to be a combination of technology plus consumer behavior and demand plus the regulation. Now talking about the e-mobility transformation, if you look at in the European Union achieving the accelerated scenario of about 75% of EV sales by 2030 will have huge implications on the entire EV chain and ecosystem. I think in parallel, the industry must decarbonize the full life cycle of vehicles, what we heard from the previous speakers as well, to achieve or to come closer to net zero targets. I think the incumbent automotive suppliers needs to shift the production technologies from ICE, certainly to EV, and also with more 70 million EVs by 2030, what we see on roads, industry also need to be gearing up to ensure that much amount of charging facilities are available, and also in terms of the maintenance and operations which you are talking about, yeah? And also to supply this requirements of the demand, in Europe alone, at least the energy production needs to go up by 5%. That has to be renewable. Again, if you go to thermal, it's not going to be helpful. So we need, in Europe alone, another 5% of extra energy which needs to be, augmented. So this is the sort of the trend from McKinsey, how we are going to achieve by 2030 some sort of 100% electrification. Now talking about EV, cool technology is the key. I talked about today, 1 in 7 vehicle is an electric vehicle. By 2030, in 2017, 1 in 7 was an electric vehicle. Already in 2022, 1 out of 4 is an electric vehicle. That's the penetration what we are looking at. But how did Tesla make it happen? If you look at this, there's a change in a value transportation. We see 3 sets of transportation here. First dimension being the usage. From speed, we started concentrating on safety. With safety, we started concentrating on quality of time spent. So this is leading to cars being more autonomous. So it is safer, it is speed enough, and also it gives you a comfort you need not do, it can be more productive. Second dimension being environmental. Everybody started looking from an IC engine, from an electronic perspective, environment perspective, and started moving towards electrification. And third dimension, if you see, we started sort of a chauffeur-driven vehicle that's arriving, driving pleasure towards personal happiness. And also we started looking at this cars as a third room, what you call. So we started moving towards a shared mobility. So different companies attack this in different ways. For example, if you talk about Tesla, Tesla combined electrification with autonomous because electrification architecture enables you to adopt those technologies. That's how it has been so successful. If you talk about Waymo or Uber, they try to attack electrification with shared mobility. So they wanted to go in for a shared mobility. So there are certain other players trying to meet these requirements demand through various means. So this is the major shift in the technology. But if you look at the major shift in the components in technology, look at the top, the 52% on the right side, yeah? Those are the new components which today contributes only 26% is going to double 52%. That's the challenge each one of us has. How do you gear up in terms of the technology to ensure that you are able to survive this technological change? So how is Continental addressing this? These are the 5 or 6 value drivers what we see. We are trying to address electrification not through the electric powertrain per se. We don't do electric powertrain. That's spun off as a separate company. I think my colleague in the morning, Girish Ramaswamy from Vitesco Technologies spoke about, which used to be a part of Continental before. But we are trying to address other than this. What are this user experience? With electrification, you see huge screens today, what we call a pillar to pillar. Today in a car, you have a smaller screens that's becoming pure. Second is in the architecture networking. Today, in a car, you have about 80 to 100 ECUs, all independent. But this will not enable in terms of the connected to the outside world. So it's turning into a new architecture where high-performance computers are running this. Today, if you see, an advanced car is run by 4 domain servers, one for chassis, one for powertrain, one for interior body electronics, one for interior. The prediction is maybe by 2028 is going to be one single server which will drive the entire system based on operating system, how today our mobile phones are running. So these are the technologies which are safety and motion. Safety is becoming much more important, and also you have to be quieter. With the electrification coming in, there are a lot of technology which you can bring in the existing vehicles. And also today you have got hydraulic brakes. Even in an electronic ABS or a ESC, you use an hydraulic coil. But for electrification, that's not advisable. How do you move from today's this to brake-by-wire technologies? And smart mobility. Smart mobility talking about vehicle to vehicle, vehicle to infrastructure, all this. So these are some of the products what Continental recently has introduced. The top left, what you see, the bigger screens, pillar-to-pillar displays. The bottom one called actuated sound. You know, lightweighting is very important for electric vehicle. So this is when a new innovation will come. If you talk about a car, it has about 12 speakers. It weighs about 15 kgs. These actuated speakers uses the existing surfaces of IP or a door trim to resonate the sound. You don't need a speaker. So there's a reduction of 90% of the weight. Can you imagine an electric vehicle if we're able to reduce by 12 to 14 kgs? It's equivalent to maybe 2-3 kilowatt hour of batteries. To that extent cost. So these are some of the technologies which we are coming at. For example, green caliper brakes, which are green. Tires for that matter. It has to be less noisy. It has to be much quieter than an electric car. So these are some of the technologies which Conti has been working since few years and introducing the market. Maybe I'll run through quickly. So just to talk about, I'm not going to get into the details. These are some of the cars which was introduced recently where we have pioneering technology for electric vehicle. This is ID Jazz. This is Ford Mac Mustang. And this is BMW i3. So these are some of the technologies which Conti currently is supplying in the production vehicle. So now talking about how do you make EVs profitable? I'm sure all of us have heard none of the companies are profitable today because there's no economies of scale, and also the cost of battery is much higher. That's why today car costs 1.5 times the IC internal combustion engine cost. That's why people are not buying. This is the mathematics today. If you look at this, Tesla, look at the gross margin per car, it's about $15,000. And net margin per car is about $9,000. Black is 2022 Q4 and blue is Q3 2022. So 2020 to 2020. Tesla continues to make more profits. That's why it has gone into a price war today. Look at the likes of many established players, including Toyota San. Still we are figuring out. But what has Tesla done? really, I think this is the challenge for the industry. I think that's the reason everybody is trying to benchmark with Tesla, how he is able to do that, how he is able to combine these technologies. Today, even today, if there is a software update and if you have to reflash all the vehicles on road, even for the companies like us, it takes 40 days. For Tesla, he completes at night 8 o'clock testing, and morning 8 o'clock he can flash all the vehicles. So that's the technology. So recently in Ford came with 3 big products, right? The Mustang Mach, then the F-150 Lightning, and the third one is, which was the third one? I think they had a really good sales, but they're not profitable. In one of the recent earning calls, the CEO of Ford he made, we have learned now, they did a revalidation or a benchmarking. They found in Mustang Mach-3, they had 1.6 kilometer of wiring harness higher than what is required. The weight of the car was 70 pounds more than what was required. 70 pounds is equivalent to $300 in terms of material cost. So he said, now we have learned. This was our first phase. So going forward, it's going to be a platform-based approach so that you will not have multiple models on the one single model. How do you build upon this thing? I think Mr. Karthikeyan was talking about the skateboard chassis. That's another technology which everybody is going towards. So you make the skateboard chassis. Mahindra has signed up with VW for their ID, so they will bring the chassis and put a top hat, and it looks different car. For an end consumer, it doesn't make a difference. Chassis is made by either Volkswagen or Mercedes. So these are some of the challenges which electrification is going through. Can we do it alone? Unfortunately, no, because it costs huge sort of money. So these are some of the partnership with the battery manufacturers, each of the OEMs. We need 24 gigafactories as we speak for us to meet the 2030 demand. And each gigafactory costs you a fortune. Who's ready to invest? So unless you partner with each of them, you will never be able to make it. That's why partnership is becoming much more challenging. So just example, Conti is also tied up with a couple of this thing. The first one is Varta batteries. This is for a 48 volt vehicle. The second one is for how do you charge an autonomous vehicle? So that autonomous vehicle automatically, if the charge is down, it can go to find a station and go and get charged. Yeah. So these are some of the technologies which Conti is open. This is my last slide. While all this happening, transforming the learning process very, very important. I think talent is going to make the differentiator because there's a huge shift in skill set required handling this EV plus other technologies. So in Conti, we realized this 4 years back. What we did was to upskill, unskill, reskill, cross-skill. We made our own university, what we call a software academy. Today, we have more than 700 courses where 29,000 engineers got benefited. So that we're able, because Conti is a 150 years old company. So there were a lot of engineers who were working on mechanical systems. How do you train them for an electrical system? So this is the academy which we were able to make use of in terms of training them to bring up to a level necessary where we can continue to be successful. So this is my last slide. With that, thank you very much. If there are any questions, I think time is very short, but I'll be more than happy to answer. Thank you.
Before we take few questions, can I request Dr. L. Rabindra, President, BCIC, alongside the Manufacturing Committee, and Dr. Devarajan to felicitate Mr. Prashanth?
Asbestos is not good for health. Every time you brake, it leaves the asbestos dust on the road, very like tires. So this is the green caliper where we have innovated a caliper which uses the lining, which is much more, because the challenge is distance to brake and the noise level. So we have found an alternate material which is sustainable and meets all these requirements. This caliper is made out of. This is brick. And talking about tires, you know, tires consumes energy, it's process oil, carbon black, byproduct of, again, fossil fuel, all the chemicals. To produce tires, you require a lot of energy. When in usage, it leaves a lot of carbon dust on the roads. Once the life is over, you throw it, it goes to a landfill. We are able to extract a rubber from a weed called dandelion weed, which is 100% recyclable. We demonstrated this technology as we speak. We have this for bicycle tires sold in Europe. For cars, we have the technology ready, but today, because of economies of scale, it's very expensive. We are in discussion with some of the OEMs. It's a matter of time that it will come into regular production as well.
Thank you. All right. So track 3 had been very insightful, covering manufacturing, technology, and battery management systems. Coming up is the last and the final track of this event, which will focus on skills, testing, and infrastructure. Our next speaker is Mr. Bala Fani Kumar, and he is the Director, Skill Development at Brigade BCIC Skill Development Academy. He will give an overview on Brigade BCIC Skill Academy and its initiatives. Please.
A very good afternoon to one and all here. I'll keep this as simple as possible. There it is mentioned EV Summit. So until now you heard more knowledge on EV segment, and now I am talking about the service part of the summit. So I represent Brigade BCIC Skill Development Academy, and this is a joint venture between Brigade Foundation and BCIC. Brigade Foundation has been founded by Brigade Enterprises and Brigade Group of Companies. We are into education, skill development, community health, and community development. And Brigade BCIC Skill Development Academy, in the next couple of years, we are coming up with a center of excellence, catering to the needs of all the BCIC members and the youth of Karnataka, wherein we look at coming up with best-in-class training infrastructure in construction, retail, hospitality, and manufacturing sectors. And as part of manufacturing sectors, EV, I see a lot of scope going forward. And so as of now, we started activities on ground since last 3 months, and we are currently associated with Construction Skill Development Council of India and Karnataka Skill Development Corporation. And in the next couple of weeks, we will be starting training programs in construction, retail, hospitality, and in the next quarter, we will be starting courses in manufacturing sector, wherein we are going to look at courses like machining, assembly, fabrication, and EV vehicle job roles which have immediate requirements for the aspirants in Karnataka. And you might be wondering how, and I become a big misfit for this summit today. I was also wondering, because until Friday, the 7th of April, I was not sure I'll be part of this summit and also the happening of the summit also. Suddenly, Dr. Rabindra and Dr. Devarajan insisted, Bala, you have to be there. So I thought, how do I make a presentation? What am I going to talk? Then flashed an idea that the previous speakers, whatever they say, I pick a line from each of them and put it across to the forum, I will make my 10 minutes. So that way I could say, Mr. Lakshmi Narayanan, who was very intense and vibrant about his passion for blue hydrogen fuels and green hydrogen fuels. And Mr. Girish talked about software and the advent of software in EV segments. Mr. Dalvi talked about the net zero aspects which Toyota is working on. And also he gave us the comfort that until 2050, the ICE vehicles also will be available in the market. And Mr. Gopi Shankar from Ashok Leyland, he gave us the comfort that houses will be becoming mobile e-houses will be what we'll be seeing, you know, especially with the advent of EV technology in commercial vehicles also. So if I cover all these aspects, you know, my 10 minutes will be over. So then I, you know, started looking at what is that was missing in all these presentations. And I am glad Mr. Prashanth, my previous speaker, he touched upon the skill development activities, which is the human element into all the aspects which we have been discussing since morning. And when it comes to human involvements, there is a lot of capacity development, capacity building activity which needs to be taken upon by all the OEMs or the manufacturers in the EV segment or the ancillary manufacturers like the batteries or the chips. And in fact, to tell you how vague the knowledge is in the market, I've been in the skill development domain for last 12 years with top companies like Island FS and Apollo. So a couple of years back, one of my senior colleagues, he came to me and he said, Bala, let's start some skill development training programs on EV segment. I told him, I am a business development guy. I understand how to bring in various different domain people together and ensure everything goes fine and we put up a shop and do skilling. But then I would require some subject matter experts, for which my senior colleague said, EV is nothing but a chip, an electronic chip and a battery, that's all. Then I was wondering, that's why some scooters or e-vehicles which were burning somewhere, we got the complaints, we must have seen in the paper. Some person of this kind only would have thought that day that led to that kind of an incident. So the purpose of me here, I would request all of you that there is an opportunity in terms of building awareness among the customers for the companies and in terms of getting business for the EV segments and to grow faster. And in fact, Dr. Parasuraman, he talked about the demographic dividend. We entered this demographic dividend phase in 2010, which means India has got a tremendous potential in terms of younger population. So at this moment, when we entered this phase of demographic dividend, it means India, the largest composition of Indian population is in the age group of 16 to 64, which is predominantly the working population. Whereas if you compare countries like US or China or for Europe for that matter, even Japan, they are older now and they are in the aging phase. And that's why they are looking at a lot of migrant workforce from countries like India, Indonesia and Singapore. This is an opportunity for us to capitalize on. And when I heard the presenters talking about the next 25 years being very critical in the EV segment space, especially in the automobile sector, I also felt, this is the same scenario with respect to human potential and human capital development within the country. Because in the next 25 years, this boon what we have today of demographic dividend will become a curse for the country, since all the youth which I talked about, which represent 16 to 64 years of age, they get into the aging phase. And what phase today the US or Europe or China is facing, we get into that phase. So the idea is, the point I want you all to take down home is, in terms of human potential also, there is an opportunity for us to upskill and redeploy our existing workforce, or also create newer talent in terms of courses which are niche, not only looking at employment opportunity, but also as part of knowledge sharing. Because I was just Googling some text about EV segments. You see a mix of knowledge on chemistry, a mix of mechatronics or mechanical aspects, electronical aspects and electrical aspects. This kind of a course is not available, like somebody said today. That kind of customized course is not available for the students. So there is a big opportunity of skilling the youth in the schools and colleges. And if you talk about the state of Karnataka, close to 75% of literacy rate is what we have. So the aspirations of youth for taking up such courses is also on the higher side, which is an opportunity for all of us to look at and reap the benefits out of. So I take this opportunity to thank BCIC, especially Dr. Rabindra and Dr. Devarajan, for inviting me here. And I also request all the audience here, wherever you see an opportunity, do count on us. We are good in terms of outreach and reaching out to the destitute youth who can be cycled into livelihood opportunities, not only for them personally, but also for the industry also. Thank you for your time.
Thank you, Mr. Babu. Can I ask Mr. Parasuraman to please felicitate the guest? I can also request the manufacturing committee to join him. Yes. All right, up next, Mr. Ravikaren Annaswamy, CEO and co-founder, Numocity Technologies, is our next speaker. And he will be speaking to us on electric vehicle charging infrastructure in India. He has over 25 years of experience as an entrepreneur and a business leader at Nokia Siemens Network and Siemens AG. He was instrumental in launching and scaling frugal and innovative solutions like mobile prepaid, data charging, and various VS solutions in India and global markets. He championed entrepreneurship by working as an innovation head for Bangalore site of Nokia Siemens Network. Can I request Mr. Ravikaren for the next talk?
Hi, good afternoon. I'm Ravi. I'm quite sure you heard a profile of mine, but a little bit on EV. Where am I in the EV space? It's our company, Numocity. Numocity is a digital-only company. We offer cloud-based solutions for all the EV charging infrastructure. Most of what's happening in India, we have some role to play, and we have quite a bit of experience in the last 5 years working in the space. And Numocity is also now majority acquired by ABB Sweden. So we are part ABB company also when we look at from Numocity, and we operate as an independent company in this space. So when we when we look at EVs and EV charging infrastructure, it's like this. You talk to different people, everybody will give you their opinion and what is their view on what's happening with this elephant or what they see with this elephant. So please take my views also with a pinch of salt. I'm looking at it from one of those boxes, but also what you need to remember is when we look at EV, we look at it from multiple pillars. I call it as 4 pillars of EV world. Always when we talk electric vehicles, you will think about vehicle itself, because that's the first thing which is changing. Everybody will say this is an electric vehicle because I've changed the motor, I've changed the battery, I've changed the technology, it's a new vehicle. Then the grid industry, or the industry which is giving electricity to these vehicles, will tell you it is my space because they are supposed to fuel these vehicles. So you will hear a lot of things from the electrical world. So there are 2 different people talking. We forget 2 other teams which are also talking. One is you will hear a lot about connectedness. I'm quite sure you heard a little bit before this. All of these are connected. 10 years back when we talked about automotive industry, we never talked about connectedness. We talked about grid, we didn't talk about connectedness. Here, everything is connected. So which means a telecom industry becomes very important. The IoT, the sensing, all of them become important because all of them are connected. So maybe take a guess what's the 4th pillar. 15 years back or 10 years back, we started talking about big data, cloud and analytics, right? Because the moment all of them are churning out data and everything is coming up, there is somebody else who has to collect all this data, make sense out of all this data and make money out of all this data. So which means now you need all of these industries. If you look at, we are talking about automotive industry, we are talking about electrical industry, we are talking about telecom industry, we are talking about software, cloud, computing industry. So all of them have to come together to make things happen. I think that is what is important when we look at anything we talk around electric vehicles or charging infrastructure. We need to remember that it's a multi-player ecosystem. Unless all of them do with an open standard with whatever they do across these systems, you will not be able to successfully do it. The other goal also companies like us, we also have is In India, EVs and whatever we do with EVs, charging or automotive vehicles, we have to do it very systemically. That is something we stress upon. We all love innovation, we love our way of quickly doing things, but that should not give way to unplanned infrastructure, unplanned networks what we create. It should all be very systemically done, standards based, so that we can actually scale faster. Now it's a small industry, but in 10 years' time, we will be growing and rapidly growing. At that time, what we do now should not hinder us. I think that's something which we think about and use when we discuss about all of these. So I will not take much time on this topic. Why electric vehicles? I'm quite sure you all know, or maybe you heard it from in the last one day. Of course, reduces pollution is the argument you all know. It's something which we all understand. When we go towards electric vehicles, it's less number of components. So serviceability is easier. Maintenance of these vehicles are much more easier. And of course, in terms of fuel price, it may, I have another slide which I don't have here, but I talk about it. Just if you go back and think, when did we start talking about electric vehicles? It is not 10 years, not 20 years. It's actually 150 years back. In 1880, 1850s is where we had only electric vehicles on the road. It was all lithium-ion, not lithium-ion, sorry, the older battery techs which were used, which was all on the road, lead-acid batteries. And in fact, sometimes if you want to see how battery swapping was done, you go and see a video coming from 1800s and you will see how the battery swapping was done. These vehicles went out of fashion in 1900s, also with Ford coming with Model T. One of the reasons was the fuel prices. At that time, oil was so cheap that electricity was expensive, and we all moved towards gasoline-based vehicles, whether it's petrol or diesel. But 100 years later, now electricity is very cheap, so we are all now talking about cleaner mobility, and at the same time also to look at how to move towards electric vehicles. But one thing we need to ask ourselves when we are all talking about it is it really carbon neutral? Because we may be reducing pollution at one level, but for generating electricity, we may be polluting at another level. So when as a country, when you look at adoption of electric vehicles, you need to really think holistically. Are you really reducing pollution at all points of thing? And also remember, batteries are pollutants after it is used. After 6 year, 7 year life cycle, you will have a new cycle of pollution coming up. So all of these are important. So let me jump quickly into this topic on electric vehicle charging. This is a graph from CEV where a little more reliable data, which you will find on how many vehicles, how many chargers are coming up on ground. This is India numbers. I think interesting to see the last 2 years growth. The number of vehicles were very small for a significant period of time. In the last 2 years, that is 21, 22, 22, 23, you will notice that we zoomed into 500,000 vehicles, now 1 million vehicles last year. I'm quite sure this year we will see more. But where are these vehicles and what are these vehicles? If you notice, it's actually electric three-wheelers, which was a good percentage of these vehicles what we sold. Two-wheelers and then three-wheelers. Cars and other segments are a very small percentage. It says something when we look at this data point. We need to remember that when people talk about electric vehicles in other countries, we are talking about starting from Tesla and cars. So when we build infrastructure, the infrastructure is built for a different kind of vehicles. When we build it in India, we need to see a very different spectrum of vehicles, which means the infra you build has to match that. So just a pointer to remember, always don't need to see cars as the only ones. In our case, it's actually two-wheelers and three-wheelers, which is the mass market. I think, so whatever we build, whatever we think in terms of systems, we need to think in these lines. And also a pointer for everybody here, if you are an entrepreneur, innovator, please remember that not too many have solved this problem. Because in most countries, three-wheelers are not the big population, two-wheelers are not the big population. So whatever tech we build, we cannot just borrow from somewhere. It is time that we build what is meaningful for us. I think that's where we also take pride in building things for Indian market, designed for Indian market, because it should work. So you will see vehicles across the segment. You will see from the tuk-tuks to, or rather the electric e-rickshaws, to smaller form factor two-wheelers, load-bearing three-wheelers, which is very popular segment. You look at cars and buses, trucks not yet, so you will see all of these vehicles in different form factors when you see. But because today we are talking EV charging infra, you see at the bottom, the requirements are very different across all these vehicles. When you take a low voltage three-wheelers, we are talking about lead acid batteries, and a charging requirement are just a socket. And sometimes you can do a battery swap of these because it's easy to swap these batteries. When you look at the smaller two-wheeler vehicles or the regular two-wheelers, you're looking at AC sockets to charge, which is actually a regular 16 amp socket or a 32 amp socket. You don't need anything else. And on top of it, if you're a little more want to give a fast charging experience, you may have a DC fast charger, but a small fast charger, which charges only the two-wheelers. So I think it's a very different segment when you look at it. When you look at the three-wheelers, which are load-bearing, or a passenger three-wheelers from Piaggio and others, you will look at a 3 kilowatt charger, 7 kilowatt AC chargers. You may do a battery swap. It's not mandated that you can do battery swap. You need to have the stack to do it, but you can do it. But the moment you move towards car and above, you will see now a different kind of charging infrastructure which you need to worry about. You will bring in AC charging. Typically, most popular one are 7 kilowatt chargers, which is what you get when you buy a car now. They may give you at home. You will see but that is a type 2 connector. It is not a regular socket. So suddenly you will see a different connector coming in there. At the same time, when you go to 11, 22, these are all physics. You take your 22 to 220 volts and the current, keep multiplying, you will get 7, 11 and 22. I think that's all it means. You're just using different current and the voltage. Nothing else. With the regular socket, you will play around and you will get 3 types of AC chargers. And then once you go to DC is where you can do a lot of things. You take a regular power, what you get. Now you amplify to get higher voltage, higher current, but DC. Not AC, but DC. And there you can build any capacity you want. And now it depends on actually the vehicle and the BMS on the vehicle, how much can the vehicle take. Because if the vehicle cannot take, you can have a 360 kilowatt charger, it doesn't matter. It's like we have built a lot of fast chargers here. Only few vehicles can charge on that, the others can't charge. You can't take a Nexon and insert it into a 160 kilowatt charger and expect it to charge in 5 minutes. It won't happen because the BMS is not designed to take that voltage and that current. Whereas maybe you can take an Audi or a Porsche Taycan and plug it in, it will charge in 15 minutes. So you need to know which vehicle you are using, what kind of vehicle, whether the vehicle can take those power, and the charger, is it compatible? Sorry. Having said about the charging infrastructure, now the way we fuel these vehicles is the paradigm of fueling itself is going to change, because you are not going to look for a fuel station to charge them. You will look in one of the segments, but most of the time you may probably charge all of them at your home or at your office, which is now a very different segment where you are not fueling your existing vehicles. You will see office, you will see work, you will see parking, public places. Highways and public places is very similar to the fueling stations, but all the other places, if you notice, they are not really a place which you are used to charging. And also you should remember now, we are also trying in many places the charging to come to you rather than you going to a fuel station. Can the fuel station come to you? So if you are in office and you want to charge your vehicle, you book, somebody will carry a battery with sufficient energy with a charger to charge your vehicle. I think these trials are going on in different parts of India now. Whether it's economical, whether it makes business sense, we will figure it out as the days go. But it is being tried in California, it is being tried in India. We will find out whether it works from a business point of view. Does it make sense to carry a battery, heavy battery with the charger in a vehicle, which is hopefully an electric vehicle, you bring it to your location and then charge. But attempts are being made and we are doing that. So what I wanted to leave a message here is, when you look at fuel station with electric vehicles, don't imagine a petrol pump kind of a scenario, because always you should remember that any of these vehicles take 15 minutes and more than 15 minutes. Typically, if you take a Nexon to a 30 kilowatt charger, it takes 45 minutes to 1 hour. So you cannot be doing it the same way you do in a petrol pump. Now you go, you're done in 5 minutes. Here we are talking about 45 minutes to 1 hour. And with extreme fast charging, we are committing 15 minutes. So you need to have a place to park. You need to have a place to probably drink, smoke, eat. And most important, we figured out in our businesses, people search for, is there a restroom or a toilet there? Otherwise, in a highway, people don't want to stop in a place which does not have it. It's not about restaurant anymore. All our customers are actually building toilets along with the chargers. I mean, it may sound different, but that's business sense, because if you don't have it, people will not come there. So very different way of charging. And I think that is something I want all of us to remember. So I talked about where are the chargers, how many chargers do we know? You will hear claims from every different people that I have 10,000 charging points, 20,000. So it's all, we should take it with a spoon of salt or maybe a cup of salt. The official numbers are not known. Nobody knows the numbers, but this is the officially put number, that there are 5,254 charging stations by the minister. So I would probably take this number because that's officially on the records number. And it's about all the chargers which are available in India, which is in public. This is not the home charging unit, so we are not counting home chargers here. We are talking about only the public chargers. And the ratio is not so good. If you look at our vehicles, we're talking about a lot of vehicles, total 20 lakh vehicles, but less than 5,000 chargers. As a ratio, it is not good, which means it is still running, which would also mean that a lot of home charging happens. Charging is happening at home, not in the public spaces. So this is growing as we are talking. We are adding several hundred chargers every month, every day. So probably the expected target is by 2025, we should have 500,000 chargers. 500,000 is the number Niti Aayog presented 4 years back, that we need to target or reach 500,000 chargers. We are at 5,000. So you know how much we need to go and how much work needs to be done. And that's where it's exciting, because we are in a very, very early stage and we need to reach that number. And 500,000 is still a small number. I think that's a targeted number for 2025-26, but probably we'll reach a couple of million chargers in the next 10 years. So when you're building this infrastructure, there are many players, and you will see multiple players coming in. You will hear the utility companies talking about charging infrastructure. You will hear oil and gas players talking about charging infrastructure. But you will see a lot of private players. We call them charge point operators or CPOs. They are the ones who are investing. These two are also called CPOs, but they are a slightly different category because they already have physical place, they already have the distribution infrastructure, they are able to do it faster. A lot of fleet players are installing EV charging infrastructure. So whether it's logistic fleets, whether it's a retail fleet, a lot of fleet players are doing it. For doing all of that, you need a charging infrastructure. You need a software to manage this charging infrastructure. But most importantly, we all forget, which I don't want to put it in the thing. I think we had somebody from Brigade talking before me. It's actually all about real estate. All of this can be done. Only thing you need important is real estate. So this business is all about real estate, real estate, real estate. If you have place, the location should be right. The place should be proper electricity, the rest will work. But you need to get that first. If you have it in a wrong place, nobody will charge there. Nobody comes to that location. Yeah, in simple words, I talked a little bit on the broader sense. What does this mean? You heard two terms from me, AC charging and DC charging. AC charging means you're using the existing infrastructure, but the car has the rectifier. It is converting the AC to DC inside the car. Because the car is already a big vehicle, it does not carry a big charger inside. It carries a small box, which means the throughput will be very slow. That's why when you connect to an AC charger, the car charges very slow, because the car does not have the capability to do a fast charging. However, you have other connectors directly given, which is CCS, CHAdeMO or GBT, with which you can give fast current. Now it is limited by the BMS. Depends on what BMS can take, you get limited. So either you do AC outside, DC inside, or you do AC conversion outside to DC and give DC. So that's how the AC and DC chargers come out. How to spot them, you go everywhere, you will see now. If you want to see close by, probably go to KR Circle and Bescom office. They have kept all the chargers. You can walk in and have a feel of how all the charging infrastructure is. You will see all kinds of chargers inside. Of course, battery swapping is other alternate technology I'm not covering today. When I look at this EV charging infrastructure, three things to remember. Where is the energy coming from? How am I giving the energy? How is the energy being utilized? I think these three things for us to remember. The challenge when the energy comes in and when I'm giving the energy is, now India has multiple types of chargers because of the nature of vehicles you saw. Each vehicle has a different requirement. Car and above uses, India says we will use all three standards, which is GBT, Chinese standard, CHAdeMO, which is Japanese standard, CCS, which is European standard. So the car's connectors, it's like the USB, micro USB, lightning, it's a Type-C connector. It's exactly the same when you talk about it. It's just that the cars take a particular socket which you can insert. There are 3 types of sockets. India right now, most of the cars are on CCS. We have very few imported CHAdeMO cars. We have older GBT cars. The cars which are few years old are all GBT. But unless we standardize this, we are going to have a challenge, because this is like CDMA versus GSM, WiMAX versus 4G. You can always compete against these 2 technologies. You need to choose one to scale. Otherwise, each infrastructure is expensive to install. A lot of us talk about total carbon neutral, right? And that's why I want to use solar energy. Where are we using? Till now, I never used the word solar. I just wanted to bring it in. Everybody's trying to use solar because that's what makes sense. And in India, once in next 5 years or maybe by 2030, when we reach 25% and above in solar being part of our energy mix, then it makes a lot of sense. I'll try to close in a few minutes. I think I'm taking a little more time. So another challenge I want all of us to remember when we talk about charging is our grid is very good. We are power surplus, but our distribution is not the best. So if we are loading the grid at wrong points, we may have unwanted issues. So we need to take care. So load management is going to be a major challenge in the coming years when you go ahead with a large-scale deployment of charging infrastructure. And charging we want everywhere. People want charging to be easy, simple. I go everywhere, I want to pay. Some people even now are saying, can I talk to the charger? I want Siri inside, I want Alexa inside. Can I talk to a charger? Maybe we will do that. So a lot of things happening, but payment is very important, how easy you can pay and how easy you can move on. Of course, when it comes to bus and other transport, you will see other means of charging also coming up, pantograph-based charging, which uses ultracapacitors to do charging. So you will see a lot of these being trialed out. I think there is a plan to do it in India. A lot of other countries are already doing it, but this is a very different technology, but will help urban transport. I mean, city transport, it may be the best solution. When I said all of that, we are connecting all of these dots. There is a lot of software. V2X, V2 everything, vehicle and charger is talking to everybody else. Unless you talk, nothing really happens. All of them are workflows and each one of them is getting standardized, and unless you use standards, it will not work. One last slide before I conclude. This is all about the topic, but also I'm part of IEEE and I lead a working group on EV for India and Asia Pacific from standards point of view. We are looking at multiple aspects. We are looking at what standards should come into India and what standards should not. And as part of that, we have multiple working groups. One of the group is on skilling. We are working very closely with a lot of universities in Karnataka to start with. And we are looking at how to enable engineers, how to enable technicians, how to enable students, how to build a workforce which can actually cater to the ecosystem. We look at it as an ecosystem play. That today we may have only skill requirement in one sector, but across once the EVs become popular, we want everybody on the street to be able to fix an EV and somebody to understand how to design an EV, design a battery and software, everything all across the table. So we are working on that, and also there are other working groups which are looking at various aspects of the EV ecosystem. Last slide before I enter. This is an image which you may not have seen, but if you have seen, you know. This is during the pandemic when there was a total ban of vehicles on the road. This is the NASA image which showed the red was the pollutant level in each of the cities. If you see the last image, which is not a good thing to do. We took off vehicles for a different reason, but one data point which is interesting to see is when you take off the vehicles, the pollution level reduced in the urban cities. I think that is something which is a wrong byproduct, but yeah, a byproduct which we can take some learning out of. Thank you, and I think this is also the time for us to align with our SDG goals as a country, and I think EV charging is one towards it. Thank you.
That was insightful, Ravi. Can I request Mr. Murli to felicitate our guests along with the manufacturing committee? Thank you. Moving to the last but an important topic which cannot be missed in EV Summit, which is electric vehicle testing and validation. Talk by Mr. Shivakumar Balakrishnan, Vice President, Product Quality and Validation, Ather Energy. After completing post-graduation from University of Florida in Mechanical Vibrations in 2001, Mr. Shivakumar worked on vibration containment across different products in a research-based company in Minneapolis. In 2003, he decided to come back to India to work with TVS Motors in the area of product validation, where his major focus was on bringing the road to the lab. After 10 years of working in the two-wheeler industry, he got an opportunity to improve on the same for the four-wheelers and joined Tata Motors as part of outdoor testing team. Was in charge of durability attribute, working on products from Jess to Nexon for the period of 5 years. At Ather now, he is heading the product quality, product validation areas. Can I request you, Shiva, to deliver?
Okay. Hello everybody, good evening. I'm starting with two challenges already. One, this is the last presentation of the day. People are in a mood to leave. And second, the previous presentation was really good. So upping that is going to be a huge challenge. So just a little bit about Ather. So the topic is electric vehicle product development I'm going to be covering this from a validation perspective. So you will see the development of how the electric vehicle development process is, and also we will talk about the validation within that process. That's how the presentation is actually going to be. So this was, Ather Energy was founded by Tarun Mehta and Swapnil Jain, and pretty much you know the other details, so I'm not covering a lot of this here. So we have 450X, and it was built grounds up. Most of the components that go into the Ather vehicle are designed and validated by us. Few are bought out. So if you look at our high-level development process, just like everybody else, we have got 5 or 6 different phases, right from concept phase to support phase. And each of these phases is very similar to any other automotive processes. So in the design phase, we actually look at concept phase, we look at product definition. We also look at speccing the product here. And in the design phase, we do a detailed design. Coming to the development phase, this is where the first level of validation happens, which is design validation. We connect the DFMEA to the test here. And in the production phase, we actually do PFMEA, PFDs, and end-of-line testing sign-off happens here. And finally, in the support phase is where we actually do the process validation, and we sign off on the product and wait for field feedback to come in. So why do we need to validate a product? I mean, the validation happens from two different perspectives. From a quality and a reliability standpoint of view, how do we actually meet those targets? So here we will be talking about how a reliability target setting typically happens. Once a product is conceptualized, the considerations there are the business plan, the competition and market strategy defines what kind of targets you want to take up. And then baselining becomes important. This is one of the biggest challenges that EV industry faces. If you actually look at a vehicle that's been, let's say engine vehicle that's been there in the field for 20, 30 years, the baselining is there automatically. So you know what are the field failures, you know what are the challenges, what are the complaints in the previous products, everything is known to you. In the case of EV, the baselining is a big challenge. You don't get the baseline data that easily. Because the products are out in the field only for 3-4 years, you don't know how it is performing in the field. You will have to sort of extrapolate a lot of information from these 3-4 years that the product is in the field. And so the reliability targets that you take, it becomes a huge challenge there. Considering all these things, still some baselining is available and you will have to use that. So you use that for your target setting. Then comes your design and application. So is the component that is being used in the vehicle a new component, completely newly designed component, and what is the application it is going into. Is it a known application? Is the application going to change? These are all considerations that you will have to have when you are setting the reliability target. At the end of all these considerations, you finally arrive at the target, which is if it's a carry forward item, if it's what is the change impact, and what is the product development plan, and what is the risk. So all these put together will arrive at what is your reliability target. Now, then attention matrix is sort of given here. So if you look at, it's an application versus design matrix. So let's say, just to give you an example, a wheel rim is a very conventional application and a conventional design. So the risks involved in this is quite low. If you actually go for an aluminum chassis, the application is quite conventional, but the design is relatively new. So not many people have aluminum chassis in their vehicle, so we will not know what the challenges with that design are. So that's actually a risk that we are carrying. When it comes to new application, transmission is sort of it's a sort of very conventional design in the industry, but when you actually have an open transmission and it is prone to dust and other things, then it becomes a sort of new application in the field. Now the biggest challenge is the fourth box there, which is both new design and new application. So in that, if you look at it, it's things like dashboard and battery will come into this. Dashboard, because it's actually exposed to the complete environment. It's sitting on the vehicle. You don't even know what happens if a stone falls on the dashboard when it is parked condition. These are all considerations that you don't know the answers for when you are launching a product. So the focus area typically becomes the last quadrant, which is high risk dashboard and battery. Then you move your upway. So this is how the reliability target setting happens. Now, once you have figured out what you are going to do, you allocate the reliability across different systems, and where, when you say same, it just means that is the baseline for you. And from there, depending on the application and the design, you either increase the reliability or you decrease the reliability. Finally, you work out what is the cost involved as well. So, now finally coming to the product development process basis this reliability. So the first step is to figure out what to test. Now that you have got the reliability target in mind, what is that you are going to test for? The second becomes how much to test for, so which is based on data. Third becomes how do you test for, so this is the third thing you have to figure out. Fourth is when do you want to test for? Do you want to actually do it in design phase? Do you want to do it in product phase? Process phase? What is the time for testing it? And finally, what do we achieve and what is the reliability goal? So are we meeting it or not? So this is how the overall process is set. So basis this, the validation strategy is arrived at, which is from inputs are basically attributes are nothing but specs for you. Then comes the DFMEA. Then comes the customer use cases, and finally field failures. All these things become input for you to move to what kind of DVP you will arrive at. And the output becomes either issues, spec tuning, and test reports and lessons learned, which goes into the new product, which goes into the next product. So how is your typical smart EV vehicle different from other vehicles that are there in the market already is? Generally the distribution of your overall vehicle itself changes. So the focus on mechanical, the focus on electrical, the focus on smarts, the focus on cloud, everything has an equal percentage as far as your smart EV connected vehicle is concerned. This is a huge difference. So no longer can a validation engineer or a design engineer just be sort of, okay, I am a good mechanical engineer, I know how to test. It is not sufficient for you in this industry. There are a lot of things that are changing. You should know about software testing as well. At some point in time, you will learn this, and you will have to understand the challenges of software testing compared to your typical hardware component or a mechanical component that goes into the vehicle. Yeah, so the typical components that go into our vehicle are, let's say, battery, BMS, motor controller, DC converter, peripherals controller, dashboard controller. So these are all, I'm just listing out the hardware components that have gone into the vehicle. And how is our software architecture? So if you look at the bottom box, which is basically the microcontroller network. So there is a dashboard microcontroller which connects to the dashboard, and which in turn is connected to the cloud. And within the microcontroller network, which is BCM, BMS, motor controller, there is a connectivity as well established. So all the data that is actually exchanged between the microcontroller network is connected to the dashboard, and through the dashboard it goes to the cloud, and which in turn is sort of connected to the public. When you want to charge your vehicle, this data gets exchanged between your public charging infrastructure and home charger as well. And all these things get data from vehicle sensor network. So this is how the complexity of our architecture is. Now coming to the validation flow, this is a typical V validation is what we call in the industry. So from a customer voice, we actually move to first speccing the vehicle level attributes. So you can actually talk about vehicle acceleration performance. So what is the 0 to 40, let's say 0 to 40 kmph, what is the time you are sort of looking at, becomes your first level data here. Then from that data, the system level characteristics are defined for things like weight, powertrain, wheels and tires actually get defined at that stage. Third level comes at the subsystem level. What kind of motor will you use? What kind of motor controller will you use? All those things get defined at the third level. The fourth level, we are coming down to the component, which is, let's say, a battery or a motor. So this is how the flow happens. And actually the validation typically flows up. So once you define what is the spec on the battery, you test the battery, and then you move to the next level, which is a battery plus, let's say, a motor controller. Then you go into weight, powertrain, wheels and tires validation. Finally, you do a vehicle level validation and then sign off. Sorry. So then move to SOP. So while the spec flows down, the validation flows up. So now let's just look at how a battery is validated. I'll just give you a few examples and then move on. So when you look at the battery, there are a lot of design considerations in a battery. Things like performance, energy, what level of consistency are we looking at, how is the battery supposed to be balanced. There are many cells in the battery. Balancing of different cells in the battery itself is an art actually. So you should ensure that they don't go into imbalance, otherwise the range and capacity drops drastically. Then how is the BMS integrated into it? What is the firmware validation? How is the mechanical integration? What kind of sensors do you use? How many thermistors are there for you to actually take care of it in case of, let's say, temperature measurement and things of that sort? What is the safety mechanism inside the battery? How many fuses are there? What is the reliability of the battery? Then the state of charge and state of health monitoring, how robust is it? Serviceability, how easy to service the battery when things go wrong in the field. From regulatory aspects, a lot of new regulations have come in on the battery now. So how are you meeting those regulations? And then what about the handling and storage guidelines? Things like, you cannot just leave a battery on for 1 year in the field in the worst case environment and expect it to perform. So even a stored battery has to be carefully stored so that you don't get into thermal runways and things of that sort. So how do you account for all these things? So from these design considerations, a set of parameters get evolved for validation. So those validation criteria ranges from, let's say, thermal validation, vibration validation, humidity, vehicle interactions, electrical, salt spray, certification. So all these things are sort of defined on this. The ones in the gray boxes are typically specs. So when you say IP67 or IP65 or IP66, you know fairly well what is the testing I need to do. Whereas in the certification also standards are very well defined. Whereas the rest of the yellow colored boxes are things that you will have to figure out how to validate. It's not just, okay, that there is no standards available right now where you can just pick up and say, okay, this is how I'm going to validate it. It requires a lot of fine tuning. It requires a lot of thought process about how to validate this. Either if you don't get the procedure right, either you will end up over designing these components or under designing these components. Both are tricky and critical. So I'll just take you through a couple of examples at component, vehicle and system level validation. So when you talk about electrical functional testing in a battery, this is actually a way of BMS testing. So we don't use a battery here. All we do is we actually simulate a battery and we test the BMS. So the tests that typically get done in the setup are voltage sensing, current sensing. So we assume that there is a battery available, and let's say some current comes from the battery. BMS is sensing that particular current or a voltage or a temperature. How accurate is the BMS in its sensing? This decides how how robust the battery is going to be. If the BMS doesn't sense things properly coming from the battery, then you are bound to have problems. So, and what kind of calibrations we need to have will also get defined based on this. Suppose let's say you test 10 BMSs in this setup and you realize that in the current sensing, the accuracy of current sensing is plus or minus X. Accordingly, you need to take care of it in the production as well. If you mess it up here, then obviously what you are doing in the production will also go wrong. So, this is the critical piece. So, examples of another example I am trying to give you here is a performance testing at system level. So, the battery, motor controller, motor, transmission and wheel typically becomes your overall powertrain, and this defines your performance of the vehicle. Now, sorry. So power transfer, thermal, system efficiency, interactions, all these things play a critical role in defining the overall PRD aspects of the vehicle. What is PRD? We call it as this is actually what customer feels at the vehicle level. So performance, range and drivability. So in the performance, we talk about acceleration, we talk about top speed, we talk about gradient performance, we talk about consistency. In the range, we talk about true range, then there is IDC range, then thermals, consistency, all these are factors that play a role. Then as far as the drivability is concerned, we talk about vehicle response, region feel, steady state response. So these are all factors that are actually felt by the customer, and important that you validate it. Now, what are the different kinds of validation we do for PRD? We actually do a mileage and energy consumption, we do a road load simulation, we do autonomous riding, then the ambient conditions, airflow conditions, drive cycles, all these things are factors, noise factors that will actually impact your final PRD numbers. So, our testing journey to sum it up, what are the challenges we faced, how did we overcome it? When we started 5-6 years back on the testing journey, we did not have, an in-house test setup also. So, a lot of these tests we started at vehicle level, and then we moved it to external labs a lot. And at some point, we felt the test cases improved so much even in the external labs that we realized that, we have now got a core bunch of tests which probably we can use to justify in-house requirement, and slowly we moved to the in-house justification. So, we always have questioned the existing test, which has helped us to actually move from vehicle level to component level and sub-component level also in quite a few cases. Examples, even at vehicle level today, suppose let's say you have a vehicle and you are testing it and you are doing thermal test on it, it typically takes 4 hours for you to cool down the vehicle before the next set of tests happens. Now, this cooling down is not part of your test at all. You end up wasting these 4 hours on a vehicle because you don't have a choice here at this point in time. So, is there a way to reduce the cool down? There are ways. There are spot coolers available. So, you'll have to figure out these things, and then what we have done is we have moved from 4 hours of cooling time to, let's say, half an hour now on the vehicle to cool down from 50 degrees centigrade once you heat up the battery and the motor, to bring it down to, let's say, 40 degrees right now. And second is, let's say, IP testing modules. Initially, let's say on a battery, we are actually using the complete battery for testing IP. You don't need the complete battery pack with all the cells inside it to the IP. All you are looking at is the ceiling of the battery. So you can use modules of much smaller sizes to do this, and this is also another way of reducing it. These are all random examples that I am trying to give you, but what the message here is, don't just stick on to one test which you have standardized. Always look at left shifting them. Focus always on left shift, moving vehicle level test to component and so on. So, how can we do the PRD which is currently being done at vehicle level to a component level? So, one of the ways is you actually do an efficiency test at each component level to figure out, let's say, what is the motor efficiency, what is the controller efficiency, what is the transmission efficiency. Once you have all these things, then you put together and figure out what happens at the vehicle level. If you are doing a transmission testing, is there a way to do belt testing? Is there a way to do pulley testing? So, these are all things that you'll have to look at. Third major chunk is use of data. EV vehicles have a lot of data in them, and it's important that you use the data properly. Software testing is an entirely different piece. It doesn't fall into any of these bits and pieces of other testing. So you will have to keep it aside and treat it slightly separately from rest of the testing, because software keeps changing every 15 days, every month, and the cycle times are very, very short. You don't get more than 2 weeks to evaluate a software. And if you merge it with the regular validation cycles, you are not going to make it. So keep that separate and make it as a layered validation where everything else remains the same, only software changes. So just 2 more slides and then we will be done. What are the potentials of EVs, future focus areas? One of the things that we have not realized is EVs can improve themselves over a period of time. So today, let's say a customer comes back to you and says after, let's say 4 or 5 years, that his range is dropping down significantly. There are ways in which you can actually improve the range sitting here at Bangalore, and you will probably be able to improve the range of a vehicle that is running in Jaipur by opening up the battery capacity slightly. This was something that was never possible before, so you can actually do it here. Just giving you small examples of how the EVs improve themselves over a period of time, and they need not follow the same service intervals, or you need not actually call the vehicle to the service. Eventually there will be a time when EVs don't come into the service center at all. Most of them you will be able to actually look at the data and say when the EV needs to be serviced. You will be able to follow a schedule for different customers for different customers in different manner. EVs generate a lot of data, and lot can be achieved with this data. We are yet to figure out. We have just at the tip of the iceberg as far as the data is concerned. So last 2 more slides and then we'll be done. Major challenges in EV development so far that we have experienced are non-availability of electronic components. So I think the whole industry went through a one year of phase where nothing was available. We realized that counterfeits are available in electronic components as well. We didn't realize it at that point in time. When a few components went to India, we realized these were counterfeits. So it has opened up a lot of avenues for us to actually control the way components are coming in, where to source the components, how to source the components, and things of that sort. Lack of products that can be customized for EV space. So we don't have specific components made for EV space, unlike for the other automotive components. Test tracks, expensive test rigs availability has been a challenge. Test tracks you have GARC at Chennai, but nothing in and around Bangalore. Otherwise, you'll have to go up north to find test tracks, unless you have your own. So software changes in the homologation areas. Slowly, the government is also opening up now, and there is a healthy dialogue in terms of what we can touch and what we cannot touch. Charging infra standards are yet to be developed. There are committees working on it right now. There is a lot of movement on this, but still we are probably few months away before we can see robust standards coming in the charging infra space. Another big challenge is electronic industry changes very fast and components become obsolete within a few years. For instance, 2 years back, the cells that we were using, no longer those cells are available. So what do we do to service a battery pack in case we need to? How do we give a spare support for 7-8 years that we need to give? So these are all challenges. And manpower, a lot of people spoke before me as well. More software and electronic trained manpower is needed, and that's something that we'll have to overcome. Last slide, opportunities in EV development. As a lot of speakers spoke before me, growth is going to be humongous in the EV segment, and how each company handles this growth qualitatively and quantitatively is going to define their path. Tier 1 and Tier 2 industry needs to mature in the EV space, and there is a lot of scope here. Data processing and automation of analysis is expected to play a huge role. So a lot of data is coming in, and we have not done justice to the data so far. So that's something we will have to look forward to. Private and government partnerships in supply chain. A lot of things are happening right now. Even semiconductor manufacturing is slowly coming into India. So a lot of things on the private and government partnerships are happening, but this needs to be accelerated. Certification is evolving fast, and lots of advances expected going ahead in this area as well. So that's all. With this, I end the presentation. Thank you very much.
Thank you, Shiva. Can I request Mr. Chandramouli to please felicitate our guest? So since you did not have a smartwatch, I thought to tell you that it's time to do some activity. Can you request the manufacturing committee to join?
Thank you. But I have a question also for yeah?
If the committee permits.
I'm just using this mic, not to give a speech, only a question. I remember when TE Connectivity made a presentation, there are so many points of connection in a vehicle. Almost, I think the video showed some hundreds of points. So what about the reliability of these connections? I'm talking about the hardware, physical connections. Can you just throw some light?
You want to hold this?
I was not there during TE connectivity presentation, so I'm not sure exactly. But basis, yeah. So basis what the connectors that we use in the vehicle. For instance, let's say the battery connector that we use in the vehicle is a different sort of connector. The regular wiring harness connector that goes into the vehicle is a different sort of connector, and the requirements for each of these connectors are different. The battery connector typically has to be a IP67 protected connector, and whereas if you look at the other wiring harness connectors that we can package within the body panels or styling components, we don't need to actually protect it to that extent. So depending on the requirement of how accurate the sensing has to be and how much of IP protection is needed and environmental protection is needed, the connectivity gets defined and the OEM decides to spend on it. So that's how the connector generally goes. I don't know whether this was the question. Yeah. So. Reliability in the sense? Sure. Some of these connectors we don't allow the customers to actually play around with. Some of these connectors, those things will not affect. So, I mean, that's what I'm saying. So, if you look at the battery connectors that we use, that's a completely different sort of connector, and it doesn't get loosened also. It requires efforts to even pull out, and there are tests available. For instance, if you talk about the test, there are cable pull-out tests, there are vibration tests that we do from the connector perspective as well. So, these ensures that the critical parts are safe on the vehicle, and the signal flow is sort of ensured, the environment is sort of protected. Yes, there are other connectors which we don't so much care about. We just cut, and wherever required we actually service it as well. So it depends. So yeah.
Thank you. I would now request Mr. Prakash G, Chairman, Manufacturing Expert Committee, BCIC, and Chief Operating Officer, ACE Designers Limited, to present the vote of thanks.
So good evening. I think it's very calm, looks like. So good evening. I think once again I request loudly that each one say good evening. I think we have to energize ourselves. Still a full day is left out. First of all, I would like to thank the BCIC office bearers, Dr. Rabindra, Dr. Devarajan, and Mr. Verma, for guiding, encouraging, and supporting the EV Summit, as the event of such magnitude and scale is being held after a long gap of 2 years and more specifically focused on manufacturing. This has actually encouraged us to start working on the next mega summit. With the permission of President, I would like to announce that we are looking at manufacturing summit. Basically, yes, I think he has already given. Go ahead. Make in Karnataka for US dollar, $1 trillion economy in the few months from now. My sincerest thanks to our distinguished guests, past presidents, sponsors. I think we have a good amount of sponsors here. Mercedes-Benz, Sundaram Motors, Bescom, TE Connectivity, NTTF, EDS Technology, Karnataka Renewable Energy Development Limited, Fronius, and many more. And also the industry leaders, the speakers who are there today, about 16 of them. I just try to note down each one of them, their key points, and the last one I could easily remember is the attention matrix from Aether. That's the reason I think everybody is still sitting here with greater attention. Until this, I think about 150 participants have, delegates are there. I think this is a very good, from start to end, we have about this kind of a strength. Looks, I mean, this is actually a very, very good respect to the entire summit itself, EV summit. So we had enlightening key points from every chief guest. Gnanendra Kumar, Mr. Kamal Bali touched upon partnership is the new leadership, and he also stressed upon the point of collaboration rather than competition. From Ashim Sharma ji, actually from Nomura Research Institute, I think the key point was on sustenance and sustainability are the two things which we should look at separately. And from Dr. P.A. Lakshminarayan, who is a former technical advisor of Simpson, I think that was a wonderful presentation. In fact, a lot of knowledge. Probably many of us were only focused on the user part of it, but I think he touched on the core technology aspect of it and focused on more on green hydrogen. And Mr. Girish Ramaswamy of Vitesco Technology, I think he touched upon various e-drive products. Mr. Sudeep Dalvi of Toyota Kirloskar Motors, I think he has given a good amount of hope, saying that 2047, till that we will have an IC engines, which means that there is a lot of work, there is a lot of business for all other industry as well. Mr. Gopi Shankar from Ashok Leyland, I think he touched upon various aspects of safety management, thermal management, and also I think the key skills, driver for skill adoption. And Dr. Rahul Mathur of TE Connectivity, I think the key sentence was every connection counts. I think today we had a good connection of 150 people assembling in this hall. And Mr. T.R. Parasuraman, I think he gave a complete overview of technology, the manufacturing, the overall development, and how things are going in all aspects. I think he touched upon everything what is there right now. And Mr. Rabindra Saha actually touched upon a very important aspect of the PLM framework, systems engineering, immersive experience. Probably, I think a lot of this has come in one go. It has come I mean, a lot of technology related new developments have come. And Karthikeyan, I think he touched upon the digital vision, a robust design flow. Prashanth Doreswamy actually talked about I think he shared his experience on technologies beyond EV, and also I think interesting part of the green caliper, energy consumption for, I think he gave one important aspect is energy consumption for EV will be much higher than IC engines. I think it's an important aspect. That means to produce an EV, we require more energy consumption. That means we need to work on that also. And Mr. Balapani Kumar, BCI skill development, I think while right now the skill development is set up for the conventional manufacturing processes, and they also realize that I think it's time we switch over to look at other new technologies, and I'm very sure that BCIC skill development will work on that. And Mr. Ravi Kumar, I think it was, the first slide was really enlightening that how each one of us looks at this EV technology from pneumocity technology. I think energy as a service was one of the things which he looked at it. And interestingly, I think this is one area which I feel that we also need to look at is IEEE Standards Association. I think because of so many, there is no standards in the, this kind of a production. It's important that we work on establishing certain standards. As we saw from Mr. Ravi Kiran also, the types of connections what we have for charging, it's still very high numbers. And last but not the least, it's Mr. Shivkumar, and I think important point was on development and validation, and I just hooked on to the attention matrix to be attentive. So that's about the speakers. Basically, we thank them for not only sparing their invaluable time, but also enlightening us with their experience and knowledge on the various topics of EV. I would like to extend my gratitude to our delegates and their organizations who have nominated them from across the industry sectors, and last but not the least, basically students from academic institutions. I think a big round of applause to the academic institutions who have participated for accepting our invitation and gracing this occasion. I am sure each one of them have a big takeaway from this summit to prepare their organizations or their institutions for the future. Thank you, Rabindra Sahab, who pushed the throttle to speed up the preparations along with the other members of the committee and also the BCI Secretariat led by Niranjan, Mr. Shama, and well supported by Mrs. Rupa and Rajeshri, and also Purushottam, who helped in planning and preparations towards the smooth conduct of this summit. Last but not the least, a big thanks to our Master of Ceremony, Richa Sarna, founder and COO of Tech Science, for steering all the sessions. Of course, we have overshot by about 20-30 minutes, but still so many sessions, and we were able to limit it to about just about 30 minutes. So big thank you to you, and I request all of you to stand up and give a big round of applause to the entire team who have organized here. I also appreciate the efforts of management of Hotel Lalit Ashok for support, for the overall management, and many more who have directly or indirectly supported and helped us to conduct this successful summit. And kindly excuse me if I have left out any. With this, we come to this end of the session. Thank you very much.
How can we miss out thanking you, Mr. Prakash, spearheading the manufacturing committee? Can I request Dr. Devarajan to also felicitate the efforts that you have taken all the while. Hold on, just be ready. Yeah. Feedback form being sent electronically to all of you. Please spare some time and do share the feedback about the event. That will help the team to do better in the next ones. All right, I'm being facilitated. Thank you. Today was a big cost.